SQL or Structured Query Language is a standard database language that is used to create, maintain, and retrieve relational databases. Started in the 1970s, SQL has become a very important tool in a data scientist toolbox since it is critical in accessing, updating, inserting, manipulating, and modifying data. Understanding this, we have come up with this SQL tutorial. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now, let's have a quick glance at the agenda. We will start off with an introduction to DBMS and SQL. Then we will learn how to query data with SQL. After that, we will work with joins in SQL, and finally, we will work with Windows functions in SQL.
So we're gonna do this week, this course is called Database Management System, also called as DBMS. Have you heard about it? What it is? DBMS? So anybody, any idea? What is DBMS or what is database? It is some place where you store data. So just a quick review for my knowledge. How many are here from IT background? I got some information. Okay, so even if programming, IT, non-IT, it should not be a problem. Databases not more into programming. These are simple commands, one-line commands where we are trying to extract data out of the database. So there is a place, it's called a database, where we store all the data and then we extract data from it. Why, how, we will learn about that. But the basic concept of DBMS is there is some data stored somewhere, and as a data analyst, we have to deal with data, and in order to process that data, in order to analyze data, we have to extract that data from the database, then do some type of processing on it. So we learn all about that. And it's also called data querying and manipulation using SQL. So what is our aim? Being a data analyst or a data scientist, we want to query data out of it and we want to manipulate it. Manipulate means we want to process it. Let's say if we got information about a batsman stored in the database, we want to get that information out of it, probably try to find out its the batsman average score, okay, his age, or probably how many matches he has played, things like that. So that is called manipulation, and querying is how to extract data out of it. Okay, so why DBMS, or why we are here today doing this course? And there was another term called there SQL. So we'll talk about more about this. SQL stands for Structured Query Language, and we'll use this as a tool like you have used Python to do some data processing before. This is another type of language that is specifically made for databases. Okay, database is a special term. What happened 20-30 years back, or going back to 80s and 90s, we were dealing with only data which was structured data. Do you know the difference between structured and unstructured? Just a simple definition. Structured means which we can put it in rows and columns. Like you work in Excel, you have columns, you have rows, nicely looking data in proper format. That is called structured data. And in the beginning, when this IT thing, was blooming, most of data that were dealing was structured data. The banks were using these, the airline reservation system, the railway reservation system, and the big companies like Walmart, they were storing their transaction only in the structured format. Okay, so why? And now there is unstructured data also, right? What is unstructured data? Anybody, any example? Your WhatsApp messages, your emails, your Excel sheets, your Word documents, the images that you send, you click a picture, the videos, the audios that you send, all these things which you cannot put in a table like nice looking by rows and columns, that is called unstructured So we have to harness both structured as well as unstructured data. They say that these days 80 to 90% of the data that we generate is unstructured data. Okay, but it doesn't mean that structured data has lost its, charm. It's not like that. Many companies still extensively work on structured data. Think about your banks. Can they deal with unstructured data? No. Even one penny here and there, they are at a loss. Okay, so still many Fortune 500 companies, they deal extensively with structured data. We will teach you Python and many more other tools to deal with unstructured data, but next 4 days we're going to only work with the structured data. Okay, we will work with nice looking rows and columns, because many companies still have that as their asset, the most valuable asset, their structured data. With me? Okay, so SQL is, that's the name, SQL, Structured Query Language. So databases store structured data, and query language SQL helps us to first store data into the database and then extract data out of the database. Why? Because we want to analyze it, we want to get hidden pattern out of it, want to get information out of it, which we can use it to increase our business value, to have an edge on our competitors. Okay, we deal with sales right now. Okay, let's say we are Walmart, we deal with sales. So I want to find out what is my customer base. And then there is a database where all 1 million customers information is stored. I want to extract that information. I want to analyze it. What is the average age of my customer in this region? Okay, from which locality most of the sales are happening? Which Walmart is doing better than the other locality? Which products are going fast in this region or that region? Is there any seasonal pattern? Okay, so I want to analyze all that information. So that's why we need to extract this data, analyze it, and tell our business that, okay, this story is what the data is telling me. Okay. The primary role of a data scientist is to turn raw data into actionable insights. Very, very important. Okay, as a data scientist, as a data analyst, we want to extract that raw information, the one column which has customer age, and turn into valuable insights. The average age is this. So if we target this audience, this age group, for this product, we can sell more. We can do upselling, we can do cross-selling, things like that. Okay, much of the world's raw data, from customer transactions to medical records, lives in organized collections of tables called relational databases. So we'll talk about more of what are relational databases. Right now, just remember there is a database where we can see the structured data, and we need to get data out of it. How to store data in that database, that is not our primary focus, because when we go to the industry, the data has already been created. Somebody has stored it there. Our job most of the time is to select data out of it. So our focus mainly will be not to store data, not to modify data, but to extract data. So that will be our main focus. Clear so far? Okay, so you become an effective data scientist, you must know how to extract, how to analyze, process data using a language called SQL. And this course teaches you that. SQL is a core and foundation skill. Without its proficiency, you can hardly become a data scientist, because whenever you go to any project, any industry, they will be dealing with, and most of the time, 90% of the time, the data is not stored in some Excel or files, anything like that. It's stored in some robust database, okay, where the proper security constraints are there, backup is done, everything. So it's a very valuable asset for the company. So we will deal with all of that, so don't worry about it. Okay. So what was happening before, like long time back, 60s, 70s, when the IT things come into picture? The traditional approach was to store everything in files, like we do in our laptops, right? We have some information, quickly open a Word doc, quickly open an Excel file, we store it there. It's okay for us because we are only one person storing this much amount of data. Think about Walmart. Think about these Wall Street banks, the wealth management banks. You know how much data. Think about Citibank. How much data they have, and can you really store it in one file or 10 files? No. What is the problem? Think about, let's say this example, it's a bank again. So they have a system, they have a process for loan, they have a process for fixed deposit. You know, we go to bank, we can get a loan, can do a FD there, and then we are withdrawing money, depositing money, doing all these transactions. So let's say there are three processes. This is one of the three. There will be many more. And let's say they're not using a database. They're just using a file system, some Excel files or some Word file they are using. So how will that look like? Probably they are storing files like this. One is the customer details. Let's say a new customer comes into the bank and they need to store name, a PAN card, this, that, all the information somewhere. But probably he has not enrolled into a loan or fixed deposit, just a new customer. Okay, so there must be a file there called customer details. And then there is a file with customer loan, customer FD, and customer transaction. The problem with file system is that the files cannot talk to each other directly, you know, without any other program written on it. Okay, so they have to store the person's name, address, phone number here also, here also, here also, and here also. Okay, think about redundancy. Think about the more storage space that they need. Think about the person's address has changed. So what they have to do, they have to change it into 4 different places. We have only listed 4, there can be 10. Okay, so the problem with file system is that as the files cannot talk to each other, we have to store the whole data into one file, similar data another file, another file, another file. Okay, another problem, you know the file, how the file works, there are lines in the file. And let's say we have a customer, let's say we want to search a customer in our file by phone number. So it's a sequential search. You know what is a sequential search? Go line by line, this, find. And how slow the process is? Okay, effort. And when the file has, let's say 10 million customers, how slow it will become. How difficult it will be for us to search something. Okay, then there is also, file system doesn't know where is the phone number. So probably file system, we have written that on the 30th position in a line, the phone number starts. So how difficult it will be for the programmer or for someone to go to the 30th column and then search for that phone number, then extract the whole line. Okay, so those were the problems with file system. So we wanted to get a better alternative to store such a large amount of data. So these were the problems in the traditional file approach. Also security also, right? If we don't want to show customers address and phone number, PAN card and voter ID card to everybody. But once we give them the file access, there is no control. Okay, so that was the other problem. Multiple users. File can be used only by one person. You must be getting an error. If the 2 persons work on the same file, you get that it is locked by somebody else. You usually get that message. So again, not a very user-friendly way of dealing with data. Okay, so that's why we need a better thing, and we came up with this concept called database. Okay, what is a database? It's a collection of information organized for easy access, management and maintenance. Okay, quickly search for this phone number, give me the customer information, quickly manage if the person's is also getting loan, FD, we need not to enter the customer information again, we can just link that customer to a new FD or to a new loan. And maintenance, again, the person's address changes, easily change it one place, everywhere it is reflected. Okay, so the examples, there are many examples. We use we are surrounded by databases, telephone directory, customer data, product inventory, register, weather records, everything is in database. You do an air ticket booking, you do railway booking, you go to a hospital, there is a hospital management system where they are storing it into a database. So all structured data is stored in the database. Now there is the term called database, and there is a term called database management system. So what is the difference? So what is a database and what is a database management system? We are here, we are users. Okay, then there is this database, which is a storage space. You can think about it like a storage space where we are storing our data in rows and columns. Now the developers or the people thought that it's difficult to directly go to the database and extract data out of it. The same file system problem, probably we need to remember where it is located, its physical position, things like that. Though they came up with something called DBMS in between, where we talk to DBMS and DBMS talks to database. And what is a DBMS? It's a software. It's a software full of programs. Okay, and that is a layer between us and the database. We go to a hospital, right? There's a nurse there. She doesn't know about what is software, what is all that thing. He just opens one window, and this is a nice looking user friendly window. She enters her phone number, she searches our record, and then we are going for this test. She quickly does it. She doesn't know what is going on behind the scene. She doesn't know where the data is stored, how to fetch it, what is the physical position of it, how it is stored. Is the phone number first stored or address after that, or vice versa? She doesn't care. Okay, because there is a database management system layer in between that takes care of everything. Okay, how the data is stored, in which order, in which file, at what position. So database management system is a heavy software. Okay, that helps us to go to the database without worry about how to fetch data. So a database management system is a large software package, consists of a collection of interrelated files and set of programs. Files, again, to store data. Actually, physically, data is still stored in files. But how it is stored, how to access it, DBMS takes care of that. We as a user need not to worry about it. Okay, and the primary goal of DBMS is to provide a convenient and efficient way to store, retrieve and modify information. Clear? What is a database and what is a database management system? SQL is the only way, yes, as far as if we buy a database management system, let's say Oracle. Okay, Oracle comes with SQL, and how you can talk to data? Through SQL only. No, there is no other way, because they have made it like that. You cannot go into the file, access one file somewhere and go there at this byte number change the data. No, that that defeats the whole purpose of us different, getting separated from the physical characteristic of the data. Okay, they say that you worry about what data is telling you instead of worrying about how it is stored, how you will access it, how you will change it. They have given us a very, very easy method of doing that using SQL. Okay, so that we need not to worry about the physical location and the nitty-gritties of the data. Okay, I would request everybody, all eyes should be here, nothing on laptop. When there is a need to open laptop, I'll let you know. Okay, we'll be sharing all the resources, so just try to grasp the concept. These things will, the laptop thing, we'll do it later. We'll have enough time to do that. Okay, because these are some of the very, very basic concept of DBMS, and from the interview point of view, that is okay, but from actually understanding what is DBMS, it's very important to listen to what I'm saying and try to grasp as much as you can. Okay, so that was DBMS. So what it helps us to do: add new files, insert data, retrieve data, modify data, remove data, and removing files. So we'll do all of these things. Whatever the problem was with file system, those are taken care by the DBMS. So what were they? Sharing of data across application. Citibank, they have branches all over world. But there is only probably one database, Oracle. They must be using Oracle because only that can handle or that amount of data at one place, and everybody, probably millions of users, are using their database every day. Okay, sharing of data across application, reduce data redundancy, right? Customer data you're storing only once. Enhance security mechanism. So DBMS gives us a way that if we have a table, and we talk about, you can see Excel sheet is a table, rows and columns, table. Okay, so we store data in table form in a database. So we can provide security mechanism in such a way that, let's say if there is an employee table and I only want 10 persons in my company to see the salary column of that employee table, I can do that. I can also do it that my employee table has employees from all the departments, be it accounts, finance, marketing, and I can make a security in such a way that the accounts manager will be able to see only accounts employees, finance can only see finance employees, and things like that. So you can even go to a security at a cell. What is a cell? A combination of row and column. You can set security even at cell level. So that is the benefit of working with DBMS. Data independence. So what we call it? We call it data independence. If we directly go from here to here, we are dependent on the physical characteristic of the data. But because there is a DBMS in between, we are data independent. Means how the data is stored, how physically we will access it, in which order it is stored. Okay, has the phone number stored first and address after that, or vice versa? Has the accounts employee stored first and then the finance employees? I don't worry about that. I'm independent of how the data is stored in the database. I only need to know two things. What are those two things? Those two things are the name of my table and name of the column which I want to retrieve. Okay, for example, I should know if I want to get my customer information, I am only interested in what is their name and their email address, because I am sending them some offer. Okay, so I need not to worry, okay, the first is the customer name, then the address, then the phone, and then the email address. No, I only need to, I need to know customer name of the table, which is customer, and the name of the columns. I want name and email. These are the only things that I need to know. Otherwise, I am independent of how the data is stored, ordered, all those things. Data independence. Okay, very important term. It's also called data abstraction. So anybody talk about these jargons, data independence, data abstraction, it's a simple meaning. We are independent of how the data is stored. Okay, clear? Better flexibility. Okay, again, you know, let's say we were storing the last name as 20 characters before, right? Now we are getting more long names. We want to make the column width as 30 now, from 20 letters to 30 letters. In the file system, it would have been a disaster to do that, because you know every line comes, every position we have coded with every position. But here, lot of flexibility. You can add new columns, you can add new rows in between rows, or doesn't matter in which order you store. You can increase the column width, you can add more columns, you can add more tables. So all these things without disturbing the application that you have created over it. Like I was giving an example of hospital management system. The nurse is using it and probably they are increasing the name of the patient, the length of the patient behind the scene, and the application will work as such, no changes at all. Okay, so that is the better flexibility. Enforce integrity constraint. It's an important term, integrity constraint. It looks very fancy, but it's not that difficult. Integrity constraints mean we are validating something. We are putting a constraint on it in such a way that it is consistent. Okay, what can be the example of this? Let's say we have a column called age. So what is the first constraint, or first, to make it a good data, what is the first constraint you think about it? It can't be negative. It can't be more than 100 or 110, 120, something like that. The salary column can't be negative. Hire date can't be null, can't have a blank space in it if it's an employee data. So all these constraints which makes our data consistent, good, accurate, you can put all those constraints in the database. So while creating a table, I'll say that, let's say if it's a bank and it's their policy, they'll hire people, they can have a customer in the age group of 18 to let's say 90, something like that, whatever their policy is, any constraint which the business has decided. Okay, you can put all those constraints and the database will never be allow you to enter anything beyond those integrity constraints. Okay, so that's why when we create database, it's not a one-day exercise. It spans months. We think about what should be the type of the column. Type of the column means, is it an integer, it's a decimal, it's a string? What should be its length? What should be the check that we need to impose on it? Okay, so all of these things we can do with this. Better transaction support, we'll talk more about that. Enforce standards, and backup and recovery features. As a data analyst, we need not to worry about backup and recovery features. That's the job of the database administrator called DBA. But you should know that it is well taken care of. Okay, so we talked about database, we talked about DBMS. Everybody clear about it? What is DBMS? What is database? And now we are talking about database model. What exactly it is? It is that when we are storing data, here, how we can store data in it? There are a couple of methods we can store it. So how we can store database, that is called database model. And there are three ways of storing it. We will talk about two very briefly, and then we will talk about the third one in depth. A database model specifies how a database is structured and used. It's a conceptual tool, so it's a concept that how we are storing the data, how it is organized. and things like that. It's a blueprint for a database for software application. So these are the 3 types of data model, and they are record based. Record based means we are entering data in a row. So if it's a customer, there are 10 customers in our bank, we are storing 10 rows there, 10 records. It's a record by record thing. And the first one is hierarchical, network, and then relational, and there is something called object based also. I'll talk about that also. Let me start with hierarchical. Hierarchical is nothing. We were using it probably in 60s, 70s when the database things started. And how we store it, it's like an hierarchy, any organization chart. There is a VC here, and then the other managers there, and then the developers there. Similarly, it's a college database, undergraduate course, postgraduate course, and things like that. So when you store data in this form, it is called hierarchical model. It was okay before then. The data size was very small. The problem with this is that in order to get, let's say I ask you, please give me all the students' data or the course data under CS, computer science. The limitation in this was that you have always need to start searching from the root and then traverse your way here, which was taking, if it's a small data, still it was okay, but as the data size started increasing, this becomes very cumbersome thing. So not usable right now. I don't think there is any company who is using hierarchical, just for your concept that it was before stored like this. Then we also tried network database model, and where you have it's like a network, when have you seen the network of cables, one thing going from another? So it was similar to that. And we have links from this file to this file, and things like that. And again, the problem with this was the same. If it's a small data set, it's okay. But when the data size increases and there are so many arrows going from here, 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 it was very difficult to query data out of it. So again, we got rid of that, or it's not used that way, but still this concept is still used. When you learn about machine learning, the further courses, there is one algorithm called neural network. Okay, they use this concept for that thing. All of this artificial intelligence, what they're trying to do, they're trying to simulate our neural network, which is in our brain. They're trying to simulate it. So there also they use some type of network modeling there. Okay, so you learn about briefly in further when you will doing deep learning or machine learning, but for the database it did not work. So what we did, we moved to relational data model. It started in 80s, and what is today? It's 2019. 40 years or 30 years after its invention, we are still using it. So it's a very powerful and very, very you can say enhanced version of how to store data. We are still using it, and you go to any bank, they're still using a database. Forget about unstructured data, that is there, but their real asset is the structured data which they have stored in a relational database. Not hierarchical, not network, relational database. And how do we store data in a relational model? It's the exact same way we store it in Excel. Okay, what have we have here? So look at this, pay attention. So we have a relation named student. What is a student? So any object, let's say take Great Learning. So what will be in their database? In their database there will be a relation or a table called students. There will be a relation, or relation is same as table, relation called instructors, probably for courses, and then there is a combination of students and courses and a combination of instructor and courses. Okay, so all are their objects for which they want to do some analysis. Okay, so we store our data in a form of relation, and if you look at it, this is a student relation, and these are the columns in the relation, and we have a fancy name for it called attributes. And these are the rows, and again we have fancy names called tuples. We call them rows, we call them records, we call them tuples. Okay, the columns, we call them columns, we call them attributes also. Okay, so in relational database, we always store data like this. This is only one relation. We will probably have another relation which is courses, and probably have another relation which is a join of students and courses, because all students will not take all courses, right? And all courses will not be taken by the students. That's why we need a third relation also, which is a combination of another two relations. So we'll talk about detail into that, how we will do it, but the concept should be clear. What is relational data model? Okay, so data is viewed as existing in two-dimensional tables known as relation. It consists of unique attributes and tuples. So sometimes there can be, have you noticed here, there are nulls also here. Office phone number, nulls. What does it mean? In relational database, when we do not have any information, we do not put a blank there, we do not put a space there, we do not put a zero there. Automatically the database puts a value called null there. Null. Null doesn't mean blank, null means zero. Null means that data is not available. And there is a special way of handling nulls. Okay, so whenever you see null, it means that that data is not available in the database. Any database whose logical organization is based on relational data model, that is called a relational database. So DBMS is most of the time also called as RDBMS. Why R? Because right now 100% of the DBMSs are relational database management system, not hierarchical, not network. Last point. So what I have told you, that this is my relational data model. Relational data model. So any database that uses this type of relational data model is called relational database. So that's just simple thing, you know. What is a relational database? That uses relational data model. And what is a data model? It's a logical view of how the data is stored in the database. Clear? DBMS, so we are, you know, talking about a lot of things here. Database, DBMS, now RDBMS. Okay, there is minor difference, but it should be clear in your mind. Okay, so another example, I don't know whether it's visible or not. So again, we have customer loan records from customer loan table, and this is my customer table. So customer has customer ID, customer last name, middle name, first name, account number, account type, bank branch, and customer email. And now I want, so can you see it? In the file system, if we have a loan table, these columns would have been repeated there also. But here what we have done, what we do here, we only have this master table, you can say, which is having the customer detail, and now that customer has taken a loan. So we will not repeat these columns again, we will only repeat this customer ID in the other relation and then put a loan number against it and then amount in dollars, and that will be a link between this relation to this relation. No need to repeat things. So now that customer's address has changed, we only need to change it how many places? Only at one place, and which is at the customer details table. Redundancy is removed, inconsistency is removed, storage space is less taken. Okay, all those benefits. And a few more terms. Again, I told you these are called attributes, columns, fields, and these are called rows, records, tuples. Different books, different websites use these names, but they are all the same things. Number of attributes, so how many columns are in the relation, that is called the degree of the relation. That's just another term you can remember. What is the degree of the relation? It's the how many columns are there. And what is the cardinality of a table? It's simple, means such a fancy word, no? Cardinality, it means how many rows are there. The DBAs, they wanted to be a little bit fancy, not talking in a normal language. So degree, cardinality, tuple, attribute, simple things. But right now just remember that customer ID is the link between these two tables. That's the common key between these two tables on which we will find out what is the customer information along with their loan information in one go. Okay, our manager asked, give me a report of all the people who have taken loan from us. I want their name, address, phone number along with how much amount they have taken as a loan. So we will, later on I'll teach you how to join these tables to get the whole information in one row. Cardinality is how many rows are there in the table. So what is the cardinality, let's say, of this table? 4. What is the cardinality of this table? 5. Okay, just a fancy name, we will never use it, but it's good to know, if somebody is talking in these terms, you should be able to understand what they are talking about. But yeah, we will talk about what is the normalization and all of these things. 8 is the degree of the second table. And what is the degree? Degree is the number of columns in the table. So 1, 2, 3, 4, 5, 6, 7 and 8. 8 columns are there. So the degree of this table is 8. Right now cardinality only mean, I'll teach you what is that 1:n and all of that later. Right now just remember cardinality is how many rows are there in the table. We'll talk about it later, how the two tables are connected. Is it a one-to-one relationship, one-to-many? We'll talk about that later. But right now just simple remember that these are the fancy terms that we use when we talk about relational data model. Okay, so let me go back. So we talked about these 3 things. Record-based logical model. We talked about hierarchical, network, relational. These are record-based, where we enter data record by record. Now there is something called object-based logical model. So what is this? Let's try to understand what is this thing. Okay. So what happened when we create tables or relations in an organization? It's in the database. Okay, if somebody wants to, if you join a company today and you want to know what is their database look like. Okay, what is the database? You have joined a bank. What does their database look like? What are the different tables in it? What are the different columns in it? How they are related to each other? So to make that thing easy for people to understand, we came up with the concept of object-based logical model. And what it is nothing but a pictorial view of our tables and our columns. Okay, let's say you have let's say you have data about Virat Kohli, how many matches he has played in different continents, something like that. You have data points. Nobody will be able to understand it. Then you have a pie chart, telling us in this continent he has played this much, or these many scores he has scored in this continent. So pie chart is what? It's a pictorial view of what the data is trying to tell you, and we use it why? So that it's easy for us to understand. The same way, when we want to understand the database of any organization, we create a pictorial view of it, and that pictorial view is called object-based, because what is a table? We consider this as an object. What are the different objects in my organization, how they are related to each other. So that's a pictorial view of our database, and it's called entity relationship model. And how does it look like? It looks like this. Okay, so today you joined an organization and somebody gives you this. Nobody will have time to make you understand, what are the tables, what are the things. They will just give you this. Try, go figure. So you can get a lot of information out of this. So what are the things? It's a name says HR database. So what can you tell me from this picture? How many tables or relations are there? 7. And you can also figure out that there is an employees table, and what are the things in employee table? It's employee ID, first name, last name, email, all those things. And then you can figure it out that employees is somehow related to a department. It also has a job, and then it also has a job history, and then job is related to some location, and location is connected to some country, and there is also something called region there. So without anybody telling you this, you can figure out a lot of things about your organization. Okay, you can also figure it out. The job ID is here in the employee table. So what does it mean? That you can also figure it out that the company policy is like that one employee can have only one job ID at a time. An employee can only have one department at a time, only one manager. So these are some of the things which are not, written somewhere, but with this picture, you can figure it out on your own. And this picture is called ER diagram, or entity relationship diagram. And what is entity here? Entity is nothing here. Entity is equal to table, or entity is also equal to relation, because of the relational database management system. And then what are these lines? These lines are the relationships. That's why the name, entity relationship model. Okay, so every organization has, the DBA must be having this entity relationship model. It's also very, very important when you start building the database. Okay, so when you start building the database, the organization has just started, so somebody sits and then they draw these things by hand or using some tool. Then they do a lot of brainstorming. Okay, so this table we need here, this relationship we need, this constraint we need. So this is a massive exercise which starts with the ER diagram. And ER diagram, there are special tools to create ER diagram. I usually, in my organization, we're using a tool called Erwin, ERWIN, but you need not to worry. But there are tools which can create these type of pictures for you. And then using these pictures, those tools can create scripts. Scripts is what? It's a code which will you use to actually create these tables into the database. Okay, this is not only the picture, the tool will help you to create a picture, and then you say create code for me, and they will create a code. The code will look like this: create table employees with columns this. The language, the code will be in SQL language, and we will run it in SQL, and the same picture will be created, not the picture, actual tables will be created in the database. So whenever you go to a new organization and you have no idea about their functionality, you can just simply ask somebody, can you give me the ER diagram of your database? I just want to study it. And by only looking at it, because nobody will sit with you and tell you all about how their business runs. You can get a lot of information about their data, about what entities they deal with. Okay, using the ER diagram. Okay, what is an ER diagram? And this is, we call it an object-based logical model. Again, a fancy name, but just a picture of your database, so that everybody is on the same page. and it will never be like this. Okay, in my last organization, the ER diagram, it was printed on, I think, 100 pages, and it has, I don't know, 150 tables and so many relationships. So it's not easy, but even if you get that complicated, start from one end. Start looking at this one corner and then start, okay, how this related, then move your, traverse through the whole thing. You will not be able to get the fully everything, but we will get an idea. Clear, everyone? Again, we learned database. I'm again recapping database, DBMS, RDBMS, and now the ER diagram. Okay, so what are the red things? What do you think? What are the red things in here? The pink things? They are the keys that uniquely identify a table. It's very important for us we should not create a table without a unique key. Why? Because you don't want anybody by mistake to enter same employee twice. Then garbage in, garbage out. Okay, that is another constraint that we are putting to make our data very good, accurate, consistent, that nobody should be able to enter an employee twice. So that's why whenever we define tables, we always define their primary key. It's all, let's consider all same lines. There is no method to it. I don't know why they created these different colors. But for now, these are simple relationships. One table related to another table. And we're going to talk more about this model because we'll use this database to learn SQL. Okay, so we will spend a lot of time understanding all of these things. Okay, so this is another example. We have a student relation. And these are the attributes and these are the tuples, and another term, domain, a set of atomic values of an attribute. What is a domain of a column? Domain of a column is what values we can enter in it. Okay, for example, let's say if it's a marital status. Marital status is a column and we can enter only two values in it, single and partnered. Okay, so single and partnered will be called the domain of that column. Just another name for you to remember. Okay, so key attributes. So every table has, as I told you, key attributes and non-key attributes. Okay, and what are those? The key attributes that participate in the selection of candidate key. Okay, so let's talk about some of these things. So all the keys is column. The keys which can uniquely identify the table are called key attributes. So in this example of student, how many key attributes are there? We can identify this student uniquely by student ID, by email ID, because name can be repeated and hopefully emails are not repeated, and probably the mobile number also. So these three keys will be called the key attributes and everything is called the non-key attribute. Clear? Simple enough, key and non-key. And then I'll talk about some of how we identify the keys. There are some special names and you should be able to understand those because the database people talk in these terms. Okay, so please understand these terms. One key is called a candidate key. And what is a candidate key? Any key that can uniquely identify a table is called a candidate key. In the last example, what were the candidate keys? Can you tell me? There are three candidate keys: student ID, email ID and mobile number. So first we identify the candidate keys Among the candidate keys, we identify now which one will define as a primary key. And primary key is the one which we tell the table that, okay, this is my primary key. You cannot repeat this key. You cannot put null in this key. So usually we go with integers. Why? Because there is another, you go by searching. The searching on integers are faster than the text. So we always try to make integer as a primary key. Okay. Sometimes if there is no primary key, in some scenarios we create our own primary key and we name it 1, 2, 3, 4, 5, 6. But usually you should avoid it. What the business says, from the business point of view, you should identify the primary key. Okay, so everybody should know the difference between a candidate key and a primary key. It's confusing sometimes. What is candidate key? Any key which can uniquely identify a table is called a candidate key, and among candidate keys we pick one key and tell the SQL that make this as primary key, and that will uniquely identify the table. So these were the three candidate keys, and we pick the student ID as the primary key. Candidate keys is a concept. Please remember it. Candidate keys is a concept for us. Primary key is something we tell the SQL, code it to tell that this is the primary key of the table. Okay, we will never use we will never code candidate key. It's just a concept. But primary key, we write the word P-R-I-M-A-R-Y, primary. Okay, in the code when we are creating a table. It cannot have null value and you cannot repeat value in the primary key. And then there is something called composite primary key. What does it mean? Composite, what is the English meaning? What do you understand from composite? More than one. Sometimes in a table, we cannot have only one column as a primary key. If I go back to that ER diagram, can somebody tell me where is the composite? Here. What is the composite primary key here? In the job history. Why? Because what is job history does? It is storing. An employee can start as a developer, then he will move to senior developer, then analyst, then tech manager, then technical manager. So there can be many job IDs he has been associated with. So we want to capture that information, and we are capturing it in job history, employee ID, and then we also have a job ID. But we have made the start date as the primary key, not the job ID. Can anybody tell me why is that? Unique key is employee ID and job ID. That job ID can be given to somebody else also, because the unique key is employee ID and job ID. Why didn't we make that as a key? No, it has not already been used. This is a table. I could have made employee ID and job ID as the primary key. No, job ID will, that is the purpose. We want to capture how the job ID is changing. It was developer first, then senior developer, that analyst, senior analyst. Because for one employee, the job ID can repeat. How? I started as a developer. Okay, then I become senior developer, and then I became analyst, and then they remove. I didn't want to do the technical thing. I asked them, make me a manager. So they made me a manager. I didn't like my job as a manager. I want to go back to the technical thing. So they changed my job, and I want to become an analyst again. I don't like the management stuff. And then again made me the analyst. So I was analyst before also. I'm analyst now also. But if I made employee ID and job ID as a primary key, I could not have captured that information. So what I did, instead of making that, I made start date as a primary, as a part of primary key. Why? Because date will never come again. Right? I was an analyst in 2015. I'm an analyst in 2019 also. Okay, so that's so lot of thought process goes behind identifying what is the primary key. And we have more than one column in a primary key. It is called composite primary key. So another example, students marks table. So we have two columns here, student ID and subject ID. And it's your name, and then Python, your name, DBMS, so on. So it is not necessary we only have one column as a primary key. In many tables we have the composite key because they are the combination of things, like in this example. Similarly, in student course table, there will be composite primary key, student ID and course ID. Then there comes the foreign key. Now let's see what is a foreign key. Again, this is and department ID, and then this department is related to another table which is called the department table, and it has department ID as a primary key. And here the primary key is employee ID, and this is related to this. So what is a foreign key? Let's say I have 5 departments in my organization. Their IDs are 10, 20, 30, 40 and 50. This is accounts, this is finance, this is sales, things like that. A new employee is added, has joined us. Okay, a new employee has joined us, and I have to create a record for that employee. So I give them another employee ID, let's say this. I enter his name, whatever it is, and then I have to enter his department ID. Let's say ideally I should have picked it from these 5 departments, but I put 100 in it. Should I be allowed to do this? No. Okay, so what I'll do, I will put a constraint on it that you are only allowed to enter data into this column which is already there in the department table. Okay, it's a validation check. Foreign key is for validation purpose. It's again an integrity constraint. I don't want anybody to enter any department for my employee. It should come from whatever departments we have identified and put it in our department table. Okay, otherwise people will start entering weird things and the data will become garbage. Okay, so this is a constraint that we put. So how I will put that constraint? I will make this department ID, I will define it as a foreign key. Foreign key always connected to a primary key of another table. Okay, so this foreign key I will connect to my department. Okay, and when I define it as a foreign key, when I define it, I put FOREIGN while creating the table, that this is my foreign key, and I also need to give this is to which primary key this is related. I will define this is a foreign key and it is related to this primary key of this table. And what I am telling the system is that whenever you enter data in this department ID, it should not be anything but whatever is coming here. Okay, so that is the concept of foreign key, and it has again a very fancy name. The name of this concept is referential integrity. Again, logically also it makes sense. We are putting a reference to something and we want to have an integrity constraint. Integrity means everything is accurate. Okay, so any interview question on when people talk about did you put the referential integrity check for this column? What they are saying mean that they want to put a check that you should be able to allow enter values only from some other table. That is that what they meant. So this key here in this table will be called a foreign key, and every foreign key will definitely be a primary key in some other table, otherwise they will give an error. Yes, between the composite primary key and the foreign key. Okay, it's a totally different thing. So let's say student ID and subject ID and then marks. This is my table. Okay, concept wise, what I'm trying to save in this table, that which students have scored how many marks in which subject. Okay, so forget about everything else. If you want to store this information, what do you think what should be our primary key? Okay, so there is Sameer and then DBMS and then 70 marks. Sameer, Python, 75 marks. So people who are saying that student ID is the primary key, how will this work? No, okay, so student ID, I'll make it like this, 10 and okay, there is another table called student and it has student ID and name and things like that. So this is another table where my primary key is student ID. So that is a separate master table where I have all the students. It is possible that I have a student who has not given any exam yet. Okay, so his data will only be in this table now, but now he has given an exam and he has scored something. I want to store that information somewhere. I cannot store in this table because this table is meant only to have student information as one line. I cannot enter that same student again in that. So I cannot store the marks here. So I have created a new table where I am having 3 columns, student ID, subject ID and marks, and I want to now store that information. So if I create this is a separate table. Now tell me, student ID, can it be a primary key in this? No. And again there is another table called subject ID. Right? There is another table called subject, and subject ID is, let's say, their primary key. So here I am storing all the subjects. There are 100 subjects. The student has only taken 5 subjects. Right? So this is a master table of subjects. Now I want to find out which scores that person has scored. So I have created this new table, and now tell me what will be the primary key of this table. Then there can be another student with DBMS and there can be another student with Python. Subject ID can be, there are many students for DBM who are studying DBMS, many students who are studying Python.
So we will consider student tag and the subject tag is four together.
Yes. So in this scenario, we will consider both of these columns as one primary key, and it will be called a composite primary key. It's just a concept. We never say somewhere write composite. It's just a concept. So in this scenario, we will use a composite primary key. Foreign key has not entered in our picture yet. Okay. Now we will add the foreign key thing in this situation. So where will the foreign key comes? Now I wonder, there are student IDs in this table. Let's say I go directly into this table and try to enter a student ID 100 which does not exist in the student table. which will be not a good idea. It will make my data garbage. So what I'll do, I don't want anybody to do that. What I will do, in this table only, I will define this key as my foreign key. And that foreign key is related, you have to give a table to which it is referencing. So this foreign key will reference this table. And I don't want anybody to enter any subject. It should come from the master subject table, whatever the university has defined that these are the subjects which are available. Okay, so I will create another foreign key that will be, so primary key concept is different, it's for different purpose, and foreign key concept is different and it's for different purpose. So see, the primary key is composite key, but its each key is referencing some other table. One table can have only one primary key, but one table can have multiple foreign keys. Foreign key may or may not be unique, and normally it's not unique. Think about this. We are repeating the student many times. We are repeating this subject many times. So in the main table, it will be unique because that is the primary key. It has to be unique. But the foreign key may or may not be unique. For in this example, the student table, it has a column called branch ID, and then branch ID is a foreign key to another table, which is a branch table. Sometimes we also use the terminology as this is the parent table and this is the child table. Okay, the table which is having a primary key is called the parent table and this is called the child table. And sometimes we also say that there is one to many relationship between these two tables. The one value of this can be repeated many times in the foreign key. Clear? Foreign key is a very, very important concept. So it should be very clear to all of you. Foreign key needed for validation purpose so that we don't enter inaccurate information in our data. That's why it's also called referential integrity, fancy name. But it's just a validation. Like we put a check on age, it should be between 80 to 90, 18 to 90. Similarly, we are putting a check on student ID that it should only have student IDs from its master table where the student's data is first stored. Yes, exactly. Very good point. It's defining a domain. You can enter values only from this domain in this column. So all these is interconnected. I can put SID here and can still reference to student ID. Because I am telling the table, this is a foreign key to this table. Whatever the name, it will take whatever the name we have given. It need not to match with the primary key column. Okay, so what was the plan today? So you people want a break or there was no break planned? Huh? You want a break? Yes, ma'am. You did not ask any question, but this time, yes, ma'am. It's okay. I also thought that it's 2 hours 45 minutes is going to be a little tough. Python probably will do some of the programming, but here it's more of one-liners. So probably today we're gonna do a little bit more on SQL, and again I am warning you that okay, as we do more and more things, the things become a little confusing sometime. But again, have patience. Do a lot of practice. Go through the recordings again and again, probably a couple of times. Go through the PPT, write your own notes, write your own code in the SQL, and I think you will be absolutely fine. So yesterday we covered the theoretical part of DBMS and then some of the theoretical part of SQL. We told you there are different command groups. Anybody? Okay, so should I give you 5 minutes to talk, then we can start. Yes? You have paid for this class. I will be more than happy to give you 5 minutes. Okay? So you have all the time, to talk among yourself. You're gonna be in this course for a long time. So just, pay attention here, because that's what you have paid for, and that's why you are here. So catch up on your gossip later, or even if you're discussing something related SQL, hold on to that. First, let's go through what I'm teaching, and then we will talk about, I will discuss with each other, with me, things like that. So which command groups? So SQL has many commands. We have only done select yesterday. We're going to do only select today also. But again, we have a number of commands and we have categorized those commands. Anybody has any clue what are those categories? The first one is DQL. We did select in it. Second one is DDL, which is data definition language, where we change the structure of the table. Then we have DML, which is the data manipulation language, where we change the data, okay, where we change the data itself. Then we have DCL, which is the data control language, grant and revoke. And the last one is TCL, which is the transaction control language, commit and rollback. And we're going to talk about more about that. We are very much interested on this thing, DQL. Select statement. So we did 2-3 clauses in the select statement yesterday. So we have select. What other thing we need to definitely have in a select statement? From. And we did one more after that. No, in is an operator. In is like equal to. When we, in where clause we define employee ID equal to this, not equal to this, less than, greater than, in. So that thing will come here in the where clause. What is an alias? Giving another name to a column. Can we use aliases in the where clause? Can we use aliases in the order by clause? Yes. So these are some of the things that you should be clear about. Okay, so we were working with HR schema, and the homework was 2-3 things. I think that WECP thing, everybody has done that? Yes, because that will be counted and evaluated. They are taking care of that. So please make sure you finish that. And then there was one take-home exercise. And you're going to, I think, submit it to them. You find it out how to submit, and they're going to evaluate that also. And the third thing I gave you, the my questions list, a classroom activity that is for your practice. Any query or question in these 3 things that you want me to discuss, which was not clear, you were not able to do it, just let me know and I will start with that first. Okay, so concat is nothing, it's like an English interpretation. We want to concat some things in while displaying my column. So I will say select, I will say concat. I can put any number of arguments or parameters in concat. It can be a column name, it can be any string. Okay, so I'll start with employee ID and then comma, and then I'll put space, works in, close it, this is a string, comma, works in department ID from employee. So what this will give me? Okay, so it will give me employee ID, let's say 1001 employee ID, works in 10, something like that. So concat is nothing, it's a function. You can pass it many parameters. Parameters has to be distinguished by comma. You can put column name and you can put string, or you can put anything. You can put, I don't know whether it makes sense, you can put 100 here, anything here, and that will return as such. It's just concatenating columns with strings and returning that. And why do we do it? Sometimes to write a nice report or a nice heading which is everybody is able to understand, we do that. Is it clear, the concat? Okay, question number 4, we'll start with that. Write a query to select first 10 records from a table. Yes, I did not cover this keyword, so let me cover this one also. So whenever you I'll take this example also. I only want the first 10 rows of this query, any query. Okay, I will use the keyword called limit and then say 10. I can give any number here. And what it will do, it will run this query without even looking at it first. Okay, so if there is an order by here, order by employee ID. So it will run this query first without even looking at the limit 10. So after this query, do whatever it wants to do, order by this, that, sort it, do everything. After this, it will just return me the first 10 records. Okay, so we're going to put limit 10 there and then it will return. I want to talk more about limit because I think there is another question you will have today of limit. Let's say I am ordering by salary and salary descending. So when I write salary descending, what will happen? What will be my first record? Highest salary. Let's say I want to find out first top 5 employees who are getting the highest salary. I'll write in limit 5 after this. Let's say I want to find it employees who are getting the second highest and the third highest. Second highest and the third highest. How will I do that? Okay, if I say limit 3, it will give me the top 3, right? I don't want the top one, I want second and third highest salary. How will I do it? There is a concept called offset in limit. So what will happen? Limit, what I will write? I will write limit 1. What is 1? 1 is my offset. Offset means you have to start after the offset. After the offset. And then how many records I want? I want 2 records. Okay, so when we put 2 things in limit, its meaning changes. If it sees a comma in between, there are 2 things, now its meaning has changed. Now the SQL will understand it like that. My first number is the offset. Offset means after this start counting, after this start getting data. And after that, how many records I want? I want 2 records. So this will give me the second and the third highest salary. Let's say somehow I want to find out the 5th and 6th highest salary. So 5th and 6th highest salary, I will write, don't want first 4, so I will put offset as 4 and then I will put, yes. So if you put any number after limit, the normal functionality is that it will run the query first and it will, whatever the result come, top 5 thing, whatever the top 5 records, it will return. That's pretty simple. We are limiting it to 5 records. But if we have run a query and we want result from in between the result, not the top 5, the middle 5 or something like that. Okay, we can do that also. How? In this case, we have to give 2 parameters to limit, not only 1. Okay, when it sees 2 parameters, it interprets it like that the first parameter is the offset. And offset means start after this record. Start after this record and then how many records you want? Comma 2, I want 2 records. So if I put a limit 10, 5. So 10 is my offset and how many records I want? I want 5 records. So which records I will get? Starting from 11 to 15. And what is 11? Whatever the query returns after ordering by or whatever you have given in the query. After we got the result, from there the 11th to till 15th record I will get. Okay, is this clear? Let's quickly run it also so that we'll see the result also. So whenever you open the open your SQL workbench, if you can see right now IPL, there is some other database that is highlighted. It means right now that IPL is in use. So if I write here select star from employees, you think it will work? No, it will not work, because employees table is not in the IPL schema. It is in which schema? HR schema. So you can have many schemas or many databases. You need to be in that database to access its table. So what I'll do, I can make the HR the default schema by two ways. One is double click on it and see it is highlighted. So now it is in use. The other thing you can do it, you can right click on it and make it set as default schema. So as soon as it's highlighted, only then you will be able to run the query. Clear? So if your query is not running, you're getting an error message, table doesn't exist, table, see it's written here table IPL.employees doesn't exist, because employees table is not there in IPL schema. So that's why change the schema and then run it. So let's say order by salary descending, okay, and it's gonna give me the employees with salary as the maximum 24,000 per month. Ooh, it's a month or year, I don't know. Okay, we'll check. Okay, so 24,000 is the highest. Now I want the second and the third highest. So what I'll do, I will put limit. If I put limit 5, it will just give me the first 5 records. See, there are only the 5 records here, 5 rows return. And if I want the second and third, I'll put the offset 1. It means start after 1 and then give me the 3 records, and it will give me the second, third and fourth highest salary. Okay, it will be 17,000, 17,000 and 14,000. What are the other things you can do? But I don't think you can. Okay, but sir, so how do you do? Okay, how do you do get help? So you have to, the official help of SQL is help index, and then you can type limit in it, and it will give you all the arguments that you can pass it, and then you can check whether you can do that thing or not. I don't think you can do it. Limits on the table, column count and row size. So you just check this help. Okay. Okay. So question 4 done. Question number 10. Somebody asked now in this file only. Acha, 8th also. List all IT related. Okay. List all IT related departments where there are no managers. Let me go back to this. We should never ever start writing the query directly. Just check first from which table we want, because manager is in many tables, at least in 2 tables. Okay. So never ever start going and start writing query. First go through the ER diagram, and let's say what we want to find out. We want to find out the departments which are IT departments. So where do you think the department will be? IT department means IT must be its in name. So we are looking at the department name here. So we're going to use the department table here, and the column is department name. And we want all the departments IT related which have no managers. So the other condition we have to put it where manager ID is null. Okay. So how will we do it? Department name. So we want IT can be anywhere in the department name. So let me just quickly, before I run that query, I have to do some investigation. So I will do department name from department. Okay. I'll just run this query just to see what are the different values of department name are. So you see administration, marketing, purchasing, there is an IT department. If you scroll down, there will be IT support, IT help desk. So all these departments are there. If you know this is the list and all the departments for IT starts with IT, you can write it like this, where department name like IT percentage. You can either write IT percentage, you can also write percentage IT percentage. So it doesn't matter. Right now we are only having three department. Let's try with percentage here also. Okay, now is the problem. Benefits has IT in it. Okay, so you can't just blindly write percentage IT or IT. You have to first look at your data, that what type of data you have, what are the values in the data. After having a look at it, you will obviously find out that benefits, we are not looking for benefits, we are looking for IT only, and all IT departments start with IT only. So you will remove this percentage and then you only want these departments. And they have also asked us that tell me all the departments which do not have a manager. Okay, so what other condition you will put there? See how am I writing the indentation? Manager ID is null. Okay, so you will get two departments, IT departments, where right now there are no managers. So it's not like there is a query and you just start coding it. You have to first investigate it a little bit, look at the schema, where is that table, where is that column, try to build the structure of the query in your mind, then look for the data in the department name. If it's IT, how does the IT departments look like? Is the IT at the end? Is the IT at the beginning? Okay, then try with percentage IT percentage, see the data that you're getting is good or not. If it's not good, try modifying it and then build your query like that. Okay, your expertise should be step by step doing things. We are doing very simple queries. Later on we'll be doing a little more complicated. So it's the process that going into your mind, how to build the query step by step. I am not able to build the query in the first go. I'll try the simple one, then add an and where condition, then add another condition. That's how you build it. Okay, you will never be able to write the query the very first time correctly. You have to do some research and then you will come up with the query. Yes, it's again regarding the concat function only. So we want to print a bona fide certificate for an employee, say employee ID 123. Okay, I'll come to 10th also. So there is a long string here. So what I'll do, I'm just copying it and I want to type something like that. So how will I start? I'll start with select concat and then I'll blindly put everything whatever I have copied here. Later on I will change it. Sorry. Okay. So concat, this is to certify that full name. Let me try this like this, with employee ID, and then I will close it, put comma, and then what is the employee ID? The name of the column, employee ID, and then I will put a space here, otherwise it will be just put join to this, then again comma. See how I am building it, and then again this double quotes and then space is working as, and then I'll close the string here, comma, and then I will have the job ID column, and then comma, and then again quotes, then space in department, and then close it, comma, and then department ID, comma, then space since join date. What is the join date? Hire date, comma, and then again quotes, his her annual gross salary is this, and then I will put quote, comma, and then gross salary. What was gross salary? Gross salary was salary plus salary into commission commission PCT and commission PCT and let's remove this and comma and then from employees where employee ID is equal to 123. Is it 123 is there? So, oh sorry. Okay, so how will you do it? Full name. We can put concat first name, comma, because I want to display the full name also with the space. Oh, okay, yes, you're right. So, first name, comma, space, comma, last name, comma, what do you think? Select concat. This is to certify that first name, last name with employee ID this is working as this job ID in department since hire date. His or her annual gross salary is this much and let's give it a name, certificate. From employees where employee ID is equal to 123. Good to go? Okay, let's try it. Okay, yes, because 123 is, there the commission percentage must be null. Everybody knows why we got null? Because commission percentage for the employee ID 123 is null. So that's why the whole thing it has converted into null. So let me just comment it out. Let me run it for all the employees. Let's see how it works. Okay, so you'll get the null everywhere. So let me order by certificate so that all the not null will comes above. I hope you're getting what I was doing. We have covered all of these yesterday. Okay. So you will get something like this is to certify that William Smith, okay, with employee ID. So I missed a space here. Okay. So this is to certify that William Smith with employee ID 171 is working as SA rep in department 80 since this his or her annual gross salary is this. Today we'll talk about how to change this 4 decimal places to 2 decimal places and format it properly. We'll talk about that. But whatever concatenate I have asked us to do, we have done that. Good enough? Okay. And the last one is 10th, right? 10th question, list employee ID, first name and their gross salaries where monthly gross salary is greater than 12,000. Show least to highest gross salaries in the output. Okay, so let's try this one. Show list employee ID, first name, and gross salary is salary plus commission percentage. Okay, so quickly Control A, select employee ID, comma, what else? Employee ID, first name and gross salary. First name, comma, salary plus salary into commission percentage, and let me give it a name, gross salary. Okay, from employees. Okay, so what else they want? List employee ID, first name is gross salaries whose monthly gross salary is greater than 12,000. Okay, where monthly gross salary. So I have to cut paste here. I can't use the alias. Is greater than 12,000. And what else? Show least to highest gross salary. So we have to order by what? Least to highest. It means in ascending order. So order by Okay, so you are getting all the employee ID, first name, and the highest one is 19600 and all of these, and they are greater than 12,000, so we are getting rid of nulls. But the problem with this is this, probably there is a person, yes, as is optional, as is optional. Okay, now the problem, what is the problem with this? Can anybody think about it? What is the problem with this result? By default it should do in, it's not doing it. Okay, I don't know why it doesn't like. Okay, so let's change it, remove the alias, no, not remove the alias. Somehow it's not liking the one with quotes. So let's try this one, order by gross salary. Yes, now it's working. It doesn't like the with one with the blank with the space in it. Okay, but the problem with this is, let's say there is a person who is having more than 12,000 salary but no commission percentage. So what will happen? That person will appear here or not? Because even if I am earning 15,000, my name is not there because my commission percentage was null, not zero, null. Okay, so it had made the whole thing. So the problem with this, I would have been covered it today, but let me tell you this thing only. So how we can get rid of this null value? So what I want, that wherever commission percentage is null, change it to 0. So I'll still get the people with $15,000, but null as a commission percentage. So the how to write it? So it's a very simple function. In the commission percentage, I will write if null. Okay, I am writing it, if commission percentage is null, please make it, okay, salary plus salary into, if the commission percentage is null, make it 0. If it is not null, then use the commission percentage only. Okay, I am going to do the same thing here. So do you understand what is the meaning of if null? If null means if the first parameter is null, return the second parameter. If the first parameter is not null, return it as it is. So if I am having commission percentage as null, what will this return? 0. And if I am having commission percentage as 10%, what will it return? Okay, so the function, the name of the function is if null. Same function we have in Oracle. I think the name there is NVL. So just make a note. In Oracle it's NVL. In MySQL it is if null. Both are doing the same thing. NVL, yes. Okay, let's try to run it. Let's see if it works or not. Okay, so it has worked. So even if so remember there were 12 rows before. There were 12 rows before. Now how many rows are there? 16. Because there were a few employees who were earning more than 12,000, but because their commission percentage was null, it was converting the whole salary to null. So these are small things that we need to think about, then modify it accordingly. No, the problem is with alias is that you cannot use alias in the where clause. Sorry, that is a whole different thing. You know, you're using the organization's database. They will not let you change their database. They will give you only read-only access. Most of the time, it's not possible. But you can, just type it like that and then get it. It's on in the memory. We have not written anywhere. Whenever you run this query, it will run runtime and then it will return the result back. It is not storing in any table or anything. It is not going back and changing the table. Please remember, as a data analyst, they will not let you change any data. Select statement can never ever change data in the database. Everything is on the fly. Okay, so just remember that. Yes. In where clause? That's the functionality of SQL. No. Alias. You know, alias doesn't work in where clause, that's for sure. It works in order by, but in order by also we just tried. If it has a space in it, then it doesn't work. If it doesn't have a space, then it is working. It depends on you, totally depends on you. Use it or not use it, whatever practice you choose. No, it will never give you an error. As is optional. You can give it for readability purpose, but if you don't give it, that is also fine. Yes, okay, talk to me, yes. If I don't give gross salary, I am removing it. Okay, this will not work because I have removed it. Let me say I'll give it 3, okay, and then I run it. So it is creating this weird looking column name, but that is okay. Yes. Tell me, Hariya.
You told me when we give a
Oh, it's working?
But if I
Oh, okay. With the double quotes, it's not working. It's the single quote, it's working. Okay, everybody, I put double quotes. That's why there was a problem. If you put single quotes, it will work. No, it's working. No, it's not working. It's not working. Okay. So don't worry. We have other ways to do the same thing. So I'll just do this thing. I'll take that later. If there is something on the board, then I'll otherwise if it's an individual query, I'll take it later. Okay. So I think anything else? Today we're gonna do many interesting things and I need your full attention without any disturbance of. Okay, so today's I have uploaded this PPT. Again, people come back. I'm gonna switch the sequence of whatever is in the PPT. Join, we're gonna talk about, that was after the lunch. I don't want to talk about joins after lunch because I know you will be a little sleepy. So let's start when you're fresh with joins and later on we'll do the first part. Okay, so till now we have only joined data. We have selected data only from one table. Okay, so we have only selected data from one table. Now we're gonna do data. We're gonna get data from multiple tables, and most of the time, 90% of the time, we join table and get data. It's rarely 10% of the time that we only get data from one table. Normally 90% of the time we get data from 2, 3, 4, 5 many tables and for our requirements. Okay, so now let's say how will we join data? How will we join tables? In order to join tables, we need to have, the first requirement is that we need to have some common columns for in those two tables. Okay, when I say common column, it doesn't mean the column name should be exactly same, but from the logical point of view, from the business point of view, there is two columns in each table which have same values and those two tables can be joined on. Okay, for example, let's take employee and department table. We know that employee is working in a department and we have created a master table of department and a foreign key here so that we can't put any department ID here. It should always come from there. So we know that department ID is the column which is common between these two tables. So whenever we join two tables, first in our mind we should be clear about on which column we have to join. Okay, and again the column name can be same, which is in this scenario, but it can be different also. It doesn't matter. Okay, as far as their values are logically making sense to join, we are good to go. Okay, so how will we join? So let's say this is my employee table and let's say this is the department table. So what will happen when we join? We get data which is common in those two tables. What does it mean that? Let's say I have a employee with department 10. This is my employee. I have another employee, let's say Suresh, and right now let's say that employee has not been assigned any department, he is a new joinee. And then there is a department table. We have 10 department number as finance, 20 as sales. So when we join those two tables, and again this is the department ID and this is the department ID. What do you think logically what data should I get if we want to join these two tables? How many rows will we get? What we will get? So what will happen? How does it work internally? Let's look at it. It goes here, it finds this, it tries to join this to all the values of the department and see what is its match. Where is the match? The match is here. So what it will return? It will return for Samir, 10 and finance. So we are done with this row. It go to the next row. It check. Null is here, is null here, null here, null here, null here. There is no null here. So we are done. It then starts from this thing. Okay, it matches. 10 is matched here. It will again check. The 10 is already, this record is already in the result. We are fine. It checks this. 20 says it matches 20 with anything. There is nothing there. It will leave 20. So what will be the answer? The answer is only one row. This is how internally it works. So you will get data. That's why I have drawn this diagram. Whatever is in common, whatever matches, only that thing will be returned. Okay, if we have more values here which there is no match in this table, those will be ignored. Similar way, if there are more records here, there is no match, those will not be returned. That is the normal functioning of the join. Okay, again there is some variation, we'll talk about those later, but this is the normal join in SQL. Okay, so this concept again, people, join is a very, very important concept. So please make sure that you get this. Listen to what I'm saying. So this is clear that only the matching rows, only the intersection of these two sets will be returned. Now coming back to how will we write the syntax of it. Okay, the query is give employee name along with their department name. So tell me how I will get this result. Whatever I have taught you till now, can we get this result using those techniques? Who is saying yes? How will we do it? I am asking for employee name along with department name, not the department ID. I want to see department name. This person is in which department, not the ID, because ID cannot be that, intuitive. They can be any random numbers also. I am interested in which department they are working. So the problem here is that both of these columns are in different tables. Which are those tables? Employee and department. So somehow we need to know how to join these two tables in order to get this information. Okay, so how do we do it? We'll start simply. We will do select first name, last name, comma, department name. This is simple. This is clear. We want these three columns. Now comes from. Till now we were putting only one table in the from clause. Now we will start putting two tables along with the join condition. So please look at the syntax. So what we'll do, we will start with employees, and we will also put somewhere department. And we have to join these. How will we join? We will put a special keyword here called inner join. Again, this is optional. So if you read somebody's code, probably they have not given inner, because by default it's inner. Okay, but as a start, you should try to put that it is an inner join. Inner means we only want to get this inner common data. Okay, so inner is optional, but I urge you to put that initially. Okay, so this is okay. We have done one part of it, but the other part is now on which column to join. Okay, on which column to join these two tables, and for that the syntax is on. Okay, we can put employees dot department ID is equal to department dot department ID, but usually what we do, we don't want to write this big name of tables again and again. So what do? We give them aliases. So I'll give employees an alias as E, I'll give department an alias as D. Departments. Yes, please mind my, I sometimes get confused. So it's department. So even if, please make sure that this is for the concept clearing. If I have misspelled something, so you please take care of that. Okay, on, we will write on E dot department ID is equal to D dot that's it. There can be a foreign key relationship. Physically there is foreign key relationship, but there will be situation where there is no foreign key relationship, but still if you say the data is same in both the columns and you want to join those and get some information, still you can do it. SQL will not stop you of joining weird columns. It will give you weird results, but you can try anything. You can write E dot department ID is equal to D dot location ID. You can do that also. It will not stop you to do that. It will not give an error. It will just give some weird results which doesn't make any sense. Okay. So when joining, we need two things. One thing we need is which two tables to join. And the second thing we need is on which column they need to be joined. So we will gonna cover both. So here we give that we want to join these two tables, and then it will ask on which columns you want to join. So we will give, there is a department ID in employee table also. I have just given them an alias name. Here E means employee, D means departments. So we will put on E dot department ID is equal to D dot department. If you put only till here, it will probably error it out. Okay, that you have not given the on statement with it. Yeah, but it will give you weird result which will not make any sense. So, join keyword is necessary. I'll talk about that also, but it will work, but it will not give you the right results. So, yes. Oh, okay, hold on, just get the simple thing. I'll come to everything complicated later. Then you will tell me, ma'am, please stop, don't tell me anything else. So just one by one, okay? So I want everybody to grasp this concept. Advanced things I'll talk about later. How to do with manager ID, how to do outer join, how to do other things, weird things. But first get the very basic thing, because I find my students struggle with this concept a lot. So I want to spend quite a bit of time on doing the simple things first. I don't want you to code all I's here. You can take notes in your notebook, but nothing more than that. And see the indentation how I am writing. Please use the same type of indentation. It will increase the readability. We have joined two tables and look at the output. It's so beautiful. First name, last name and the department name. Not some ID, not some code. Is this clear? Because this is a very important step, people, and you will confuse later on. So you have to fully understand this thing. Okay? Inner join will give you all the common results. So now let's try, we'll try different things and then we will do few more examples. Okay, so somebody was saying, let's say we don't give this. It will give an error, and somebody is saying, let's not even join it. So let's say give it, or you can give inner join, and let's say if, yes. Okay, so what I did, I have given inner join. I can give comma also here without the join condition. Anybody noticing before we were getting how many rows? 106. How many we are getting now? 1000, and 1000 also, because there is a limit I have set to 1000. Let me change it to 50,000 and let me run it again. 2889 rows. So what happened here? What happened here? In SQL, if you do not give the join condition, what it will do? It will do a cross join. And what is a cross join? I'll give you a very simple example. Let's say table 1 values are 10, 20, 30. And let's say table 2, and let's say the values are 100, 200 and 300. Let's say these are two tables and we have to join them somehow, but we have not given the join condition. What will happen? SQL what will do? They will create a cross product, cross join, Cartesian product. Please remember these names. Cross join, cross product, Cartesian product, all the same thing. What it will do? It will randomly, without even thinking, take this row, repeat it for all the rows in the other table. So it will put 10, 100, 10, 200, 10, 300, 10, 400. Then start with this 20, 100, 20, 200 and so on. And it will give you a huge amount of data which have no link to each other. So we are getting every employee connected to every department now. Oh, that is, I have created a comment. I have made it a comment. It's not executing. So this is the way to comment. I don't want to remove this code because I'm going to use it again. So just for time being, I'm commenting it out by putting 2 hyphens and a space. Because I told you now, for join you need 2 things. For join you need 2 things. One is the condition and one is the what type of join you are doing. So we have given it that we are doing inner join, but we have not told it on which column to join. So it doesn't have the full information. If it doesn't have the full information, what it will do? It will just do cross join by default. So if you're getting a lot of data, somehow just check your joins are good or not. Yes, so the question here is that I am joining it on, first of all, okay, I'll answer that. Is this thing clear? Okay, and we can do the same thing sometimes like this also. Instead of doing inner join, if we write cross join, it will do the exact same thing. If I put instead of cross join, comma also, it will also do the exact same thing, creating the Cartesian product. Okay, so while joining you have to be very careful. If your join condition is not good, it will give you weird data. It will not give you an error and you are at loss, spending days and hours to figure out where did we go wrong. Okay, Cartesian product, why we need it? Sometimes we need it actually to do that. Why? To create a bulk of data. Let's say I have written a query and I want to find its performance. So what I'll do, I'll create a weird table with 100,000 rows and run that query on it just to check its performance. So only there cross join is useful. Okay, people talk to me. Okay, then also the same result. Okay, I'm gonna try that, but all the combination permutations you can try it later. So cross join will give the exact same thing, 2889 rows. Let's try with doing this. So now it is, even if it's given, it is giving you the right data. The cross join, inner join, whatever you do, the main thing is this thing. The main thing is the join condition. So it's, whenever you have condition is given, even if it has done cross join, it is still applying that condition. On cross join, it has given you the bulk of data, but it has filtered it out because you have also given the join condition. No, not any join. Please don't do that. Please use inner join. That is the concept. This is just a weird thing that has happened. But you don't want to code like that. They will throw you out of the organization. That you're trying to confuse people just to check that SQL is working or not. No. Oh, okay. So I'll come to that. I'll talk about later. But right now, okay, just concentrate here. The right thing to do it. This. You can play with it. Try different combinations. It will give you some weird data, some not weird data. But this is the right way of doing it. Okay, so filtering is done on this. फायदा क्या हुआ? इसलिए because later on for inner join we will use outer join also, and I'll tell you the functionality of that. Same syntax, only inner join will change to outer join, and then what does it happen? We'll talk about that. But first understand this, do not jump the gun. Okay, so let's try one more example. Let's go here. Okay, I want to find out all the departments in city. What are the different cities? You must have played with data. What are the cities there? Berlin. Okay. So tell me all the departments which are in city Berlin. How will we do it? First of all, can we do it from one table? I want the department names, all the department names in Berlin. Can we do it from one table? No. Which two tables we need? Location and department. And what we want? We want department name, comma, city. Okay, so please help me writing this query. So what we'll do, from location, L as alias and D as alias. What else? Inner join, then on L dot. What is common in both the things? Department is not common. Department is not at all there in the locations. L dot location ID is equal to D dot location ID. What else? Where city is equal to Brazil is a country. Clear? Let's extend. Yes. Okay. So what we are doing, we want to find out all departments which are in city Tokyo. So we will look at the department table and we are not able to find city in it. So I will not be able to find all the departments of Tokyo from this table. I need to look for a table which has city in it, and I figure out locations has city in it. So somehow I have to join this table with this table. I want department name and I want city from here. So I have to join these two tables. Another thing is that on which key I have to join. So I look at it. These are joined on a common key called location ID. Okay, the common key is location ID, and then we will just use the syntax which I have told you. We will do select department name, comma city. From one table we give it a alias name, inner join department D on L dot location ID. This is the common key between them, and I'll put a condition also where city is equal to Tokyo. Let me quickly code this because I'll extend this later. I'm going slow because I want you to understand this perfectly. Okay, people, please maintain a decor, please. Locations. Okay, so administration is in Seattle, marketing is in Toronto. So these are the department where the head office is in these cities. Okay, so let's try some more things with it. So what will happen, you're going to tell me if I write it here like this. Please read the error. Column location ID in field list is ambiguous. What does it mean? It is in both the tables. SQL is asking, tell me from which table do you want, and for us it doesn't make any difference. I just need to give it the name, so I have to give it like L dot location ID. So whenever you get this error, ambiguous, column is ambiguous, it means that the one column that you are selecting or using in your query, it is in two tables, and you have to specify from which table to use. And in that scenario we can use any table, it will give the exact same result, but you have to give it an alias name. You have to prefix it. Okay, let's move forward. So let's say I want to find out all departments which are in country US. Now tell me what to do. I want, give me all departments which have their head office in country US, means the location is in US and the country ID is here, but I want the country name US, United States. Is it that is the country name, United States or US, whatever? Okay, so we're going to learn how to join three tables now. Control A, select star from. Okay, so US. Country ID is US. So let's say United States. Okay, so we want to find out, I don't know about the country ID, I just want to find out all the departments in country United States of America. How will we do it? Okay, so I'm now going to teach you how to join the three tables now. So look at the syntax, please. We have joined two tables. These are absolutely fine, right? So I'm going to put parentheses here. So what will happen now? This becomes my one table. As soon as I put parentheses on it, it has become my one table. Okay. Now I have to join this table now with another table. What is that another table? Country. So this is my location table because location is already there in this table. So I'm done with the location. I have to now join on with the country. So I'll start from here only. So this is one table. I will write inner join countries. I'll give it another alias C, and what next? on C dot country ID is equal to L dot country ID. I'll put country name here and I will do where country name is equal to United States of America. You can do that. I'm just making it a logical thing. I'm just putting parentheses in it, but still all these things, the L and D are visible here. No, that's not how it will work. This one is already defined. So what are you doing? You're taking this whole thing and making it as one table and then joining it to another table on something, and then you're getting the result. This is how the syntax is. Yes. Huh? No, I don't think so. Select all. No. I think still it will work. But logical thing is to do it that again to make it more readable. Okay, we can do many weird things here, but please try to do whatever is the guidelines or whatever makes sense. Okay, so let's try this. I'm gonna put this in parenthesis. I'm gonna do inner join countries. I'm gonna do on L dot country ID is equal to C dot country ID where country name is equal to United. This is again a very important thing. 90% of the time we'll do this only. You can talk about cross join, try this, try that, why it's not working, but most of the time, 90% of the time we do this. Inner join, joining many tables. SQL is pretty flexible. You can remove the parentheses and probably then also it works. But this is the right way to do it for readability purpose. Yes. With the help of? Okay, so what I'll do, instead of explaining it, let me show you the schema. So what is happening here? We are joining. We have to find out what are the departments in country name United States of America. So we'll start from here. Okay. We will join this. We cannot join directly to department because there is no link. The link here is from here. So we will figure it out. We have to join countries with locations first and then locations with departments. Then we will get the data what we want. There is no sequence of joining. You can join in any sequence. You can join country locations first and then with departments. You can join department location first, then with country. So there is no restriction of the sequence. Okay, but what we have done here, we have first joined these two tables using this from statement, locations L, inner join, departments D. So this was clear, whenever we join, we need to give two things, the name of the tables and on which thing you want to join. So this one clear, the first one, and then we have to join with countries also. So what we have done, I am considering this as one table and I am repeating the same syntax again. So I am repeating inner join again, I am repeating the name of the table again, it's countries now, and I am repeating on this thing exact same way. Now it will join all the three tables for me. Okay, and when we joined all the three tables, now I can pick and choose any columns from here, from here, from here. What data it will give you? It will give you the data which is which is the common. That is why this intersection. It will give me only departments which are in country United States of America, nothing else. Only those locations where the country is United States of America. Only the departments where the country is United States of America. Only the common keys, only the common rows. Nothing else. So if there is a department in Berlin, it will not show it to me. Okay, if there is a country named India, it will not show that result to me because I have put where country name is equal to United States of America. So only the common things will be pulled up. Okay, so this is the way we will join all our tables, and it will only give you the common things between them. Let me show you another example, and let's see if we can join these. Okay, so these are two tables. Again, one is the employee table and one is the department table. So tell me, if I join these two tables, inner join, how many rows I will get? Spend some time. First tell me what is the common key. So now tell me how many rows you will get. Because when we join, do a inner join, it will only look at the common rows. So we will get department ID is 12. So there is any department ID 12 here? No. So cross 11, 11 is here, tick 10, 10 is here, tick 12, 12 is not there. So we will only get Edwin and Steven's data along with their department. Edwin is in marketing and Steven is in IT. If I join these tables and do not give the on statement, do not give the join statement, how many rows will I get? If I don't give a join statement and do a cross join, how many rows I'll get? 16. Harry will be repeated 4 times. Harry will have IT department, marketing, resources, shipping. Edwin will be repeated 4 times. Stephen will be repeated 4 times. Eric will be repeated 4 times. Okay, but when we do inner join, we only get common things which are matching. 11 is matching here, 10 is matching here. Because we are joining this row, this column with this column. These are two different tables. And I'm joining this column with this column. When you join internally, it checks and matches the data. No, I'm not getting it. So there is no 12 here. You're thinking about primary key and foreign key perspective. Yes, that rule has not been applied here. This is just some random data for you to understand how the join works. Yes, is something wrong here. If it would have been a foreign key here, we would have never been able to allow to enter 12 here. But the key is not there. I have shown this example just so that you know how the join works. But again, ideally, yes. Yes, that doesn't. Yes, that is logically correct. You joined the organization 6 months back. Your ID is 100. You joined the IT department. I joined it today. Before me, many employees have joined different departments. So today my number is 150, the employee ID, but still I will be joined to the IT department, which is 10. Okay, so that doesn't matter. No, join can be done on primary key is a concept, separate concept for the validation of our table. But join can be done on any key until unless logically there is a sense of joining them. So primary key and foreign key concept is there to make the data robust. But join can be done on any keys, even if they're primary or foreign, doesn't matter, until unless the logic says that joining these two columns makes sense. So there is no restriction. I told you, you can join department ID with salary. Nobody is going to stop you. System will not give you an error. But it's up to you. That's where the expertise, that's where the domain knowledge comes into picture. Yes, those will come later. So we're going to do a lot of joins today. So those will come later. Okay. So clear, people? Inner join. Again, very, very important. You're saying this is fine. But when I'll give you a query, you have to join 4 or 5 tables. And then, you're at, you're blank. What happened? And don't worry about outer join or many other joins. 90% of the time, only the inner join will work. Okay. One more thing I want to tell you is that this is how you're going to code from now on for join. But this is the new way of joining tables. When I started my career as an Oracle developer only. I'm a certified Oracle developer. I cleared some exams. So SQL is, I've been involved in SQL for pretty long time. This is the latest method of the SQL has standardized that now you have to join like this only. Before this, there was a different method. I'm just going to show you so that sometimes you go into an organization and you have to maintain somebody else's code. Okay, so you should know that join can be done in this way also. It was used to done in an old way. Okay, it's not very different. It's a similar way, but you should know that also. But from now on, you have to do programming using this syntax only because this is now the standardized one. So we want to display employee and department, the same exact thing that we have done. Look at the first syntax. Now, are you familiar with that? Does that look okay? This is what exactly we did. Okay, this is the ANSI standard. So that's why I want you to code it like this only. But before that, we had this type of join, which was again, simpler than this. But again, no, we have to switch on this one. Select employee ID, select statement is same. From, you do not put inner join here. You just put comma here, and the join condition, instead of putting it in on, you put it in where clause. So if you see somebody's code joining like that, don't get scared that it's not joining properly. This is the old way of joining. But they have come up with this new standard. So going on, from now on, we should use this standard only. Okay, but it's pretty simple, right? Where instead of putting on, we are doing where this is equal to this. Clear? Okay, so now let's move to the inner outer joins. Okay, and let me tell you the concept of it. So cross join, everybody understood, right? Joining each table with each row with each table. Okay, so inner join, the common thing. Look at the left outer join. In left outer join, we want the common things also, but we want the table is all data also. So where does the need arise? Why do we need to do this thing? So your manager asks you, give me a report or give me data of all the employees and their departments. Okay, but I also want the departments, or let's say I also want the employees who has not been assigned to a department. Is that possible? That is possible. Let's say our database allows that the person has joined today. He is a trainee and we are not sure in which department he will go. So right now his department ID is null. Okay, let's see if we have data like this. Select star from employees. How will I find out if there is any employee with the null department ID? Where department ID is Kimberly Grant. Okay, that's a person who doesn't have a department. So the manager is asking, give me all employees, okay, along with their departments, and also give me employees which do not have a department yet. Okay, if we do inner join, if we do the normal inner join, what were we missing? What will we miss? Yes, we will miss Kimberley, because when we do join and there is a null in the join, the SQL will not pick that record, right? So we will miss Kimberley Grant, but if we want to include him also, but there is no corresponding value in the department, in that scenario, what we will do, we will use the left outer join or the outer join for that thing. So if you look at it, this is my employee table, this is my department table. I want the common things also, but I also want an employee who is not in the department. Understood what is an outer join? Outer join is, I want data, all data from one table. Doesn't matter it's in the other table or not. That table will get preference. That give me all data in this table. We are joining it to other table, but I want to get all the records from this table. Doesn't matter if it is in the other table or not. Understood? And left outer join means whatever is in the left hand side. And how will we code it? So we will code something like this. Select first name, last name, department name, from employees E, department D, on E dot department ID. We have done the exact same thing before. The only what we used to put it here, people? We used to put inner join, okay, which will give us a common thing. Now we will put, okay, so what will happen? The table at the left hand side will get preference. So even if there is data which is not been joined in departments table, still it will give you all the employees. Type it also, select first name, comma, last name, comma, department name from employees. Let's try the inner join first. Department D. I'm typing it for you people so that you understand. I'm typing it again and again. Okay, I'm running it. So how many records I'm getting? I'm getting 106 rows. Okay, let's check if there is Kimberley there or not. K-I-M-B. Kimberley is not there. Okay, because Kimberley doesn't have a department. So inner join will only give us common things, okay, which are there in both the tables. So now let me change it to left outer join. So how many rows should I get? Tell me. So there is only one person we just checked, Kimberley. So we will get 107 rows from this. And if I look for Kimberley, I think both will work, but I want you to put the left for now, left outer join. I think it will work both. SQL is flexible enough. It will, I think, give the same result, 107, but You know, later on you can remove all these things. I'm teaching you the first time. That's why I'm pushing you to write it the right way the first time. Later on, you know, when you're an expert, you will just, you know, not care about inner, not care about outer, left join, you will use that. Left inner join, I don't think there is any. It will give an error, I think. I don't know. You can try the combination. Okay, I'm coming to that. But left outer join, everybody understood? Okay, this is a little complicated concept, so please pay attention that you fully grasp it. The same thing that we did for left outer, yes. Okay, that why we have to do outer word, because the first, that is the syntax, okay, but the why we did outer join, that we need to understand. We have did outer join because we want all data of employees, doesn't matter that whether they are attached to a department or not. No, intersection. Then yes. So we will give, we want this portion also, and we want this one also. And the right outer join is exactly the same way but the opposite. So here we don't want this, we want this one. Okay, actually we not need the right outer join. We can just change the position of the tables and can go with the left outer join only. But let's say we will do the right outer join. So what is the example of that? Again, we will take the same example. We want all the departments, and there can be departments where no employee has been, you know, assigned. So in that scenario, what we will do, we will put right outer join here, and what it will do, it will give me all the departments, whether there are any employees there or not, along with all the employees also. The common one will definitely come, okay, but along with that the departments will also come. So let's first see if there are any departments which do not have a employee. How will we check? No, we can't check it like that. Okay, let's try to run it. So let's run it with inner join first again. 106 rows. Okay, so let's see if there are any departments which are having no employee. Okay, so let's run it again. So we have come up with 122 rows, and you see contracting, no employees there, IT help desk, NOC, IT support. So all these departments are there where there is no employee has been assigned. Okay, so what we did here, right outer join means the right table got preference. Give me everything from right table. Okay, doesn't matter whether it is in the left table or not, along with the common things also. So you see, you get all the department names even if there are no employees assigned to that department, and you will get null in the blank spaces. So what we have done, we have given preference to the departments table. So department table will get all the data, doesn't matter if it is in the employee table, along with the common data also. Yeah, so it depends on the position. If you're writing left outer join, the table that you want, the whole table that you want should be on the left side, and if you're doing right outer join, the table which is on the right side is the one which you want fully. But you can have only left outer join and can go away with both the things, you know. You can put the same thing, you can do right left outer join, move departments here, move employees there, it will give you the exact same thing. इनर जॉइन में हमें चाहिए कि दोनों कीज में डिपार्टमेंट आईडी एम्प्लॉय में भी और डिपार्टमेंट आईडी डिपार्टमेंट में भी कॉमन डेटा होना चाहिए, जहां पे एग्जैक्ट मैच होता है, ओनली देन इट विल कम. So when I show you this diagram, so this area is only where department ID is 10 here, department ID is 10 here. Only those rows will come. Only the common thing. If it's a null in there, it will not come. If it's a null and we want to take it. No, department ID is there. Okay, I'll show you that. So let me show you people one more thing. Let's also type in E dot department ID, comma D dot department ID. So tell me people what will happen. We'll get null, but what will be in D dot department ID? The actual value of contracting. Okay, what is the ID of contracting? That will come in the D dot department ID, but E dot department ID is null, which is true. Actually, in the table also it's like that only, na? In employee table, there is no department contracting. For that, the value is null. Okay, but in the D dot department ID, having value contracting with department ID 190. हाँ, अगर हम आउटर ज्वाइन करते हैं तो अगर यहाँ पे नल वैल्यूज हैं तो लेकिन ये वाला जरूर दिखाएगा, और अगर हम लेफ्ट आउटर ज्वाइन कर रहे हैं तो ये वाली सारी वैल्यूज दिखाएगा, वहां पे वो नल डाल देगा. Kimberley, because there was a null in the department ID in the employee table. But no, in the no D dot department ID तो 190 है. D dot department ID तो 190 है. There is no way to find out कि E dot department ID is null until unless we join those two tables. The row is not there. If you do it, it will not give anything. There is no row of the whole null in the table. Employee में पूरी row null होनी चाहिए ये दिखाने के लिए कि वो department यहाँ नहीं है. But there is no row like null for this department. Break. Okay, what is the time? Okay, one last thing. So let's say if I do inner join here, what do you think E dot department ID and D dot department ID, what will be? Only the common one. Okay, only the common one. There will be no null anywhere if you are doing inner join. So what was the homework yesterday? The 10 or 16 queries in my file. Remember, there were around 16 queries, 16, 17. Okay, and besides that, there was a quiz, and then there was this WECP as well as the take-home exercise. So in all of these, if you have any query, just tell me, and I will take you through. Whatever query you were not able to understand or not able to do. Okay, yes? Take home exercise question 3. Write a query to display the employee ID, salary and salary range of employees as tier 1, tier 2 as per the range, ordering the output by those tiers. Okay, so what do you think, which command or which operator, or how will we do it? Remember, because now there are 3 conditions. We did something similar to before. So anything sell less than 5,000 to then tier 2, tier 3. So we will use the case statement. So the problem is with the syntax of the case. Okay, so let's quickly run it. When it is with the employee ID, salary. Okay, so let's try to do it. Select employee ID, comma, salary, comma. We'll start the case statement here, case, and when salary is less than 5,000, then I think tier 1, and when salary between 5,000 to 10,000, then tier 2 when salary greater than 10,000. Is it like that? Then tier 3, and then you have to end the case statement. So end, and then you can give it a name, salary range, and then from employees, and what else was there? Ordering the output by these tiers. So order by salary range. Okay, in the case statement, please remember that you have to type when multiple times for each condition. And the other rule is that after then, whatever you are doing, the data type of that should be same. So I don't think you can, here tier 1, tier 2, tier 3, all are string. We are displaying the strings, okay. I don't think you can do a numeric, one numeric, other string, things like that. So those are some of the rules that we need to follow when doing the case statement. So let's try to run it. So if you see less than 5,000, it's giving tier 1, and if you scroll down, tier 2, and then if you scroll down, then tier 3. Okay. So case statement, when we have multiple things to do, if there are only two conditions, what operator we could have used? If this, then this, and then comma. There are 3 arguments in if. Please put your phone on silent mode. So if there are only 2 conditions, you can use the if operator, but when there are more than 2, you have to go to case. It starts with case, then when, and then you can write it like that. So this end statement is telling the system that case statement has ended. Whenever you use case, there should be an end there. We just gave it a fancy name. It's just an alias. It's just an alias name that we have given. Otherwise, if we don't give it, it's gonna print here the column name as case, when, something like that. I don't want to do it. I am giving it a fancy name called salary range. It's an alias name. We can add, let's try case. Okay, so we can try a few more things. I'm writing another case here. Let me see what are the job IDs. Select distinct job ID from employees. Okay, so let me show you a few more things we can do. So case, let's say job ID. See, this is a little different. So I'm, after the case, I'm writing the column name, and then I'm writing when job ID is AC account. Okay, when job ID is AC account, then write accountant. Okay, when it is AC manager, then manager. Else, we can also use else here. Else, okay. So here there are 2 ways of using case. One, I am putting an expression here. If it is true, then it's gonna print that. And there is another method. I am giving the column name after case, and then I am doing when this column name is equal to this, print this. If it is equal to this, print this. If it is not equal to any of these, for everything else, print other. And then I'm ending the case statement, and I'm giving it a name, and let's say, what does it give us? So it is giving us this person's job ID must have been something else. So other. But if somebody is accountant, so account ID, so he is getting as account, written as accountant. We have to mention a So what is happening? So logically think what it is doing. We are saying if when job ID is equal to this or this, print that. So we can use the case statement like this also. We can omit job ID from here and we can write here case when job ID equal to AC account, job ID equal to AC manager. So when we are doing equal things, we need not to do it in the when statement. We can write the column name above and then it will take care of, it will just do equal in the when statement. So it's another method of writing it. When we have greater than, between, then we have to write it inside the when, because now we are doing different operations. But when we know job ID, we will always check for the equal operator. You can put the job ID above and then write it like this also. Okay, with case statement, it's a very powerful statement. We use it many times. Yes. There is syntax error. Check the equal. Did you check the error message? What it is saying? Then tier 1, when salary doesn't, then tier 1 and salary range. There is no comma after salary. Comma after salary. You know, when you start case, this is another column that you are starting. So there should be a comma before the case statement. So did you see here? There is a comma here and there should be a comma here also. Case statement, when you start, it's starting a new column. Okay, so take care of the commas. Understood? Case statement? Okay, don't, try, you can take a picture or, wait for it. Tell me anything else or note down in your notebook somewhere and you can try it later. Let's move ahead. Anything else in all those homework? Think about logically, does it make sense? What exactly are you trying to do? Only then you can put group by. You can't just put group by like that. Tell me a scenario where you want to do something and then we will try to see if we can put group by here. If you want to know how many columns are there in a table, what is the command, everyone? Describe. So you use the describe table name and it will tell you how many columns are there in the table. Here we are building columns on the fly. So I don't know what is the need to get the number of columns. You can directly see it from here that there are 4 columns here as soon as you run your query. No, if you running any query, you look at the select statement, how many columns are in the select statement, those many columns are there in the query. It's going to return those many columns. Our focus should be to get some information about the data, not that much worried about how many columns or rows are there. It's to get the data and then look at the data, what it's trying to tell us. Okay, write a query to display names of employees whose first name as well as last name ends with vowels. Okay, so let's try to do that. We're going to use a function. I did not mention it yesterday, but there is a function called left and right. Okay, so let's try it. Select first name. What is the question? Display name of whose first name as well as the last name ends with vowels. Okay, ends with vowels. Select first name, comma, last name from employees where right of first name, comma 1 in A, E, I, O, U and right of, so you have left and right columns, functions. Left will give you the the characters from the left and right will give you from the right. So if you do this, substring will be difficult because to get the last character you have to first find out the length and then do length minus 1. So you can do it that way, but it becomes a little complicated. But this will give you, so it ends with vowel, it ends with vowel. it will give me the last character. Okay, so let me show you here. Right of first name comma 1. So let's say, what does it print? It's printing the last character. So if I say 2 here, it's gonna print the last 2 characters. So 3, it's gonna print the last 3 characters. Okay, right is a function, you know, like there is a function called lower, substring, instring. Similarly, there is a function called left and right. What does they do? They give us, if you pass a string to it and then you have to pass a parameter, it's gonna go in the string and give the leftmost 2 characters. So what will be the answer here? Py. So when you do write of Python and then give 3, what's gonna return? HON. So these are 2 more functions that we can do. So somebody asked substring. Let's try that also. Yes. Huh? What are you saying? Okay, so what I'm doing, we want all the first names which ends with vowel. How many vowels are there? 5. So I'm putting those vowels in a list. Okay, A, E, I, O, U, and I'm asking SQL that find out the right of first name 1. It means last character of first name. It means first name should end with a vowel. And then I'm checking after getting that last character. Is last character in A, E, I, O, U? If yes, it's gonna turn true and it's gonna fetch that record for me. Otherwise, it's not gonna fetch that record. So you see, first name, last character is I is in vowels. That's why it is fetching up this record. How many vowels are there? Okay, so think about it. How will we do it? How many vowels are there in a string? In string will give you the position at the first thing that it finds. Okay, you need to check. There is a function called find and find all, something like that. Okay, that will give you that you have found it. So check on the help, something called find and find all. Okay, so if we have to use the same thing using substring, how will we do it? Let's try it. Substring, lpad is to only pad it with few values. So let's try this. How will we use substring? So for substring, we have to do first name and then we have to find out the length of okay, minus 1 will give you the, okay, we can try that, minus 1. So substring, otherwise you can do it, find the length and can do length minus 1 also. So the substring is also, minus 1 is also giving you the last character. Okay, so substring and left we can use, or right we can use to find, to parse the string. No? Okay. So yesterday we covered many single row functions, multi-row functions, and also we covered the joins. Okay. So we're going to do more exercises on joins today, probably the left and right outer join also. So tell me, what are the multi-row functions that we did yesterday? Multi-row functions. Count and then count, min, max, sum, average, median. So these are the commonly used, but there I'm sure there will be more of those. But those are the main commonly used group functions or the multi-row function. We also call them aggregate functions. Okay. Any other concept from yesterday you want me to repeat? I'll be happy to do that. Otherwise, we'll start with the today's topics. Okay. Again, I'm asking you to practice more and more of SQL. The more you do, the better you'll become. The more errors you get, try to spend some time on what the error is saying. Try to figure it out, what it is telling us, and then accordingly make changes. It's all about practice. The more you do, the better you will become at this. Okay, so let me start with today's topics then. So we're gonna do set operators today. A little bit about those. How to use subqueries. So we're gonna write subqueries also. That is in the first part of the day, and in the second part of the day we will start with DDL and DML. Anybody remembers what are DDLs? What were the commands? Create, alter, rename. So today we're gonna do those also, not in very detail, because I told you as a data analyst you'll hardly do that, but at least if the code is written using those commands, you should be able to understand that what these are doing. And we will also do the DML, insert, update and delete. Okay, few of that. So that is today's agenda. So let me start with the set operations. You remember our maths classes? What are the set operations that we did in maths? Yes. So the set operators are union, all. We can apply the same operators in our queries also. How, we will see. But let's first say what are these set operators. Again, minus and intersect. Okay, I want you to close your laptops, all eyes here. You can have your entire life to code. This time will not come. Okay. So minus and intersect, they are not available in MySQL, so we'll not be able to run the queries, but I will tell you the concept because I don't know on which database you will work on later, Oracle, DB2, SQL Server. So at least you should know the concept of minus and intersect. Okay, so let's start with this example. We were a company who were making or selling phones, right? And this was our table of products. We were selling Nokia, Samsung, HP and Nikon. I don't know the products of these companies. And recently we acquired another company, same type of company, we acquired that company. So now I'm having, let's say, two tables. One was in their database and one was in our database. So product 1 table and product 2 table. So when I do, now the business question is, give me the list of all the products that we were selling and the new company after the merger. So now tell me what are the total products that we are selling. So which operator, so now these are two tables, we have not merged the tables yet. I just want to write a query so that I can tell my manager that these are the products that we are selling right now. So how will we do it? Which operator we will use? So when we do union, what result we will get? We will get Nokia, Samsung, HP, Nikon. Will we get Samsung again? No, because we are doing union. Union will remove the duplicates. So we will get then LG, Dell, Apple and PlayStation. And if I do union all, then we will get even the duplicates. We will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 records back. Okay. So that is the basic difference between union and union all. Okay. Next come minus. What does minus do? Okay, before we use minus, let's say what is a business question. Somebody asks me, okay, let's do the intersect first. Give me the products which we are selling as a common. They were also selling, we were also selling. Okay, so then which operator we will use? Intersect. And what will be the result? Samsung and HP, which are common. Which are common. So union is, you can say, we are covering all. Okay, union all, we are repeating even if they are duplicates. Intersect is again only this portion. Okay, and then what is minus? Minus is only this part. Only this. And what is the business question? Business question is, give me all the products, list of all the products which we are selling, okay, but they were not selling that. Okay, so give me the products which we were selling. Okay, I want to find out what are the extra products that we as an old company were selling. Okay, I'm not interested in what they were selling. I'm interested what as a parent company, what are the products we were selling which they were not selling, so that I will probably in their staff also regarding the products that we are selling. So that is probably the requirement. Okay, so there we will use minus. So this is my old company, this is my new company, acquired company. Okay, so what I want to find out, which products that we were selling and they were not selling. Okay, so I will not cover this common part. Okay, in that scenario we will use minus. Okay, minus is like doing minus in maths. Okay, how do we do it? Let's say we do A, B, C, D minus D, B, E. Just a maths concept. So we will do minus of this. So A will come here, B will cut, C will come here, D cut. So we will get this. It's the same scenario. No, I am only interested in this minus this. Okay, this portion minus this portion. So I'm only interested in finding out data from here after minus subtracting this from it. So I'm not interested in what the other company is selling. So minus will only take care of this portion and then subtract whatever the common things in the other thing and then give me that data. So if we do, okay, so we will do both ways. So let's say we do product 1 minus product 2. What will be the result? Nokia and Nikon. Okay, so Nokia and Nikon we were selling, that they were not selling. Now the business question is, tell me which products the other company was selling which we were not selling. What then we will do? We will do product 2 minus product 1. What are the products which the other company was selling which we were not selling? Probably the business reason is we want to study those products. Should we want to keep selling those, or should we just stop selling those things? Okay, so in that scenario we will do product 2 minus product 1 and the answer will be LG, Dell, Apple and PlayStation. Okay, so that is the concept behind these operators. Okay, I'll show you the working of union. I can't show you minus and intersect, but you get the idea, what it is. Okay, so let's see this. Okay, first of all, is this clear? Union, union all, it can be an interview question also. What is the difference between union and union all? Why do we use minus? You can give the same example in the interview also. Okay, clear? Union, union all, minus and intersect. No, but it will work in Oracle and DB2. You should know the concept. You can search it. We will do the union in MySQL. Okay, so a few rules also about union. used to combine the result set of two or more select statements, removing duplicates. Each select statement within the union must have the same number of columns. So that is another rule for union statement. What it is, if I am doing select, let's hypothetically emp id last name from emp1 union select employee ID name. Let's say there is another table called emp2. I'll be able to do union only in two conditions. The one condition is the number of columns defined in the first select statement should be exactly same as the number of columns selected in the second statement. So if 2 columns selected here, 2 here. If 3 here, 3 here. Okay, you can't do 3 here and 2 here. No, union will not work. Okay, because it's looking for the exact match, because the final select statement will give the columns at the same number of columns which are in both. Okay, so you can't do that. Other rule is that the data type of the corresponding columns should match. What does it mean? If emp id is integer here, employee id should also be integer. If this is text here, this should also be text. If this is date here, this should also be date. Okay, so union, or in fact all set operators, will only work if in the two select statements the number of columns should be same and their data types should be same. Otherwise they will not work. Column name can be different, but the number of columns and their data type. So here I am writing ID, here I am writing employee ID. It will work as long as they are both are integer or both are text. Okay, so that is the condition that the union and union all or all set operators require. So similar data types and must be in the same order. More than 2 queries can be clubbed using more than one union statement. So if there are 3 product tables, we can do from product 1 union from product 2 union from product 3 and so on. Union can be used many times. Okay, union can be used many times with many select statements. So you can say that union will only cover ones and union all will cover also cover the duplicates. Okay, so query to get a union of all types of managers. So we will do this query. Duplicate thing means if remember that our product example. So what is the difference between union and union all? When I'll do union, so see Samsung is here also and Samsung is here also. When I'll do union all, it will give me Samsung twice because it was there also, it was there also. But when I do union, it will remove the duplicates and will give me Samsung only once. That is the difference. Which column needs to be returned? Okay, so like in this example, what columns will return? Only 2 columns will return. Doesn't matter. So what will be my statement here? My statement here will be something like this. Select product name from product 1. Select product name from 2. So my result will be product name, only 1 column will be returned and with all the data. So let's try that. So you know it looks for removing duplicates, it looks for the whole row. Okay, so if that will not make any sense from the business point of view, but let's say if we do this. Category ID, is this category ID? And category ID. Now what will be result? while doing union and removing duplicates, it checks the whole thing. So my result will be 1 Nokia, 2 Samsung, and then 1 Samsung again. Then what is it? Okay, the different. No.
HP will be eliminated. 3 HP is common in both.
So 3 HP will only comes once because the whole row is it's looking for duplicates. So 3 HP here and 3 HP here. So when we do union all, it will show 3 HP twice. When you do union, it will show only once. So what I'm trying to do is it looks for the whole column, all the columns to remove duplicates. What we have duplicates in table? 1. Okay, you are just thinking randomly. From the business point of view, it will not make sense because this is a primary key. But if it happens, union will still remove. If we are having 2 Samsung here again, union will remove, only give us 2 Samsung. Okay. So it doesn't think, it does think that this is my result set. From where it has come, I don't care, just remove the duplicates in the result set. What about the Samsung? That will depend, we will do, we are talking about the union functionality. So in the same scenario, if there are many sub-products, we will try to get the union of those tables also again. Try to understand the functionality of union. So if you give me a sub product, we will do the same thing, and accordingly whatever the data is, the same rule will apply. Okay, come back people, come back. So let's do one example. Using our HR schema. So let's say our company has organized a team outing in Goa. Okay, so our company has organized a team outing in Goa and only managers are allowed to go. Okay, only managers are allowed to go. Now as an HR manager, I'm thinking who should we take with us? Okay, so if you look at the HR schema, I will open it. No. So there are, if you look at my schema, I am studying my schema and we have 2 types of managers in our company. Okay, what are those 2 types? So one list, I can get it, whoever's job title is having MGR. Let's look at the job titles. Okay, so public accountant, accounting manager, all of that. Let me look at only the job ID. Let's say we will do with job ID only. Okay, so can you see anybody ends with the job ID ends with MGR? That is probably a manager. Okay, then this one is also a manager. And MAN, okay, MAN is also a manager. So anybody's job ID ending with MAN or MGR, we are considering them as managers. So that is one list. Okay, then another person comes, okay, my job title is not manager, but I'm still managing team. And how will you check that? Because if you go to the employee table, my ID is in the manager ID. Okay, because I was a team leader, they did not change my job title, but still I'm managing people, so I should go to Goa. Okay, so now we are having 2 types of managers in our system, and I want a complete list of all the people who are job ID ends with MGR or MAN, those will also go, and all the people who are having their employee ID in the manager ID, they will also go. Now I asked my database person to fetch me a list. Now I'm thinking as a database developer, how will I get that list? In one query. Okay, what I'll do, which operator should I use then? Union. I will fetch data for the job ID, where job ID is manager on MAN, and then I'll union it with the query where the employee ID in this manager ID. So let's try to write that query. Okay, select employee ID. Let's write it for job ID first. Employee ID, first name, comma, last name, comma, job ID from employees, where, how will I write it? Where job ID like percentage underscore MAN, or job ID like percentage MGR. Yes. Yes. No. In looks for, I think, the exact value. You cannot put percentage in link, in. Okay. So you have to use like. You have to use like, you can't use in here. Okay. Let me run it. Okay. So 10 Nancy is going, Dan is going, Matthew is going. So how many people are going? 14 rows. Okay. So 14 managers will go. But again, I told you that there are few people who are not managers, but they are still managing teams. So we have to take them also with us. So we will write union select. Okay, so I have to exactly, yes, without the, yes, I'm just making sure that it will work with this also. But again, you know, our convention is underscore man. If there is future, if there is anyone by mistake, the man is, it's not manager, but some other thing. But with underscore, I know that this is definitely a manager, but it will work with that also. I'm just being more precise here. Select employee ID. So please help me in building this query. How will I get that this employee ID is in manager ID? Okay, so today I'm not going to use inner join because I think now we got used to of it. So I'm only going to use join. Okay, so employees E join employees M. Okay, so what we want, let's draw a pictorial picture. This is my employee table and my M ID, and this is my manager ID. To find out first name, last name of this manager. So I'll create a copy. This is my emp ID. This is first name, last name, and I will join it here so that I can find the first name, last name of all the managers. Clear? This one we did yesterday only. Self join. So M and on. Can you tell me what should I join on? Okay. I am just missing the inner thing because I think now you got used to of join means inner join. Okay, so I need to prefix these, otherwise these will throw me an error. So employee ID, what should I prefix it with? So remember, I want the employee ID of this person, not this person. Okay, I want employee ID of this person, so I will do m dot employee ID. Okay, and then job ID of probably m dot only. Okay, manager's job ID, and then m dot first name, and then m dot last name. So now can you see, I am having the 4 columns in this query and the same exact 4 columns here. Their data type is also should be same. Only then I will be able to run this query. Let's do order by, let's say do first name. Okay, so I think we will be able to do this. I think first name will not work. Here only the order works. So let's say order by 2. 2 is our first name. So everybody should be clear about this query. We are covering many concepts in this. We are covering self-join here. We are covering union here. So please take a look at this query. And if there is any question, just tell me. Okay, so let's see how many people we have to take to Goa. So we have to take 18 people. Before there were 14, I think. Now 4 many people have been added. So this is an IT programmer, Alexander, but he is managing a team. So even if the job title is not manager, we are still taking him with us because he is managing a team. He is a manager of a few employees. Okay, so go back to the story of going to Goa. We are taking our managers to Goa. Okay, so I want to find a list of all the managers. One way is to look for in the employee table job ID. I know that anybody's job ID ending with man or manager is a manager. That is the company policy, how we have defined the job IDs. So my list will come directly from here, which I have written in as my first query. Okay, but now somebody tells me, you are not taking me, but I'm still managing a team. I'm still a manager, but my job ID is not a manager. Okay, so I have to take care of them also. Now how will I find out those people who are managing other people and still their job ID is not manager? So what I'll do, I'll go to this table. For all the employees, I will find out their managers. All the employees, just give me the managers. So basically it is giving like this. Just a second. So select distinct manager ID from employees. I have to take these people also, all of them. Okay, I have to take these people also along with me. Okay, and how will I find out now their names? I have to, these are the manager IDs. Okay, so what I have to do, I have to find out their names. Their names are written here in the first name, last name. But I cannot directly use this one. I have to make a copy of this table here, and then I have to join this manager ID with that employee ID to find out the first name and last name. So that's why we have to do self-join, because I'm not interested in employee's first name, last name. I am interested in manager's first name, last name. For that, we are cloning this table. We are joining manager ID with the employee ID like here. And then I am fetching that table's first name, last name and employee ID. One is null. 18 rows. No, not new people. Probably their job ID is also manager and the other one. So we can put a check if you want that give me only their manager is, their ID is not in manager, and also we can check that also. Where job ID not like this, and where job ID not like this. Where job ID not like this, and okay, I'm doing it wrong. I'm checking the employee job ID. I have to again do the self join to check this manager's job ID. So that's what I'm doing wrong here. So, but I'm telling you here because we are not putting a check for that manager ID's job ID. Right now, it is giving me all the managers. So those managers can have the job ID as man and manager also. So if we want to check only the people who are not having job ID as man and manager, then we have to again do a self join like the one that I have done, and then check this m dot job ID. M dot job ID not like this. I was checking this job ID, so that's why it was not giving. Okay? Not getting? Okay, so let's try this. Give me all the managers whose name is not ending with manager, and so we will do employees E join employees M. Okay, and this manager ID is coming from E dot manager ID. Everybody clear till here? I'm going to put on E dot manager ID is equal to M dot employee ID, and the where clause will go like where M dot job ID, okay, where M dot job ID not like this, and M dot job ID not like this. So now I got only 4 rows. Okay, so these are the people who are managing, but their job ID is not doesn't have manager or man in it. So along with those 14 people that we have selected, you know, these 14 people, we have also take these 4 people, so total becomes 18. Okay, so in order to check this manager's job ID, we have to traverse like this. We can't use the job ID of this employee, so that's why I had to do a self join again. In this scenario, it's true, but there can be people who are not managing. I'm a technical manager. Okay, I don't like to manage people. I am still, you know, a senior level person. I don't want to manage anybody, so I will not have my ID in anywhere in the manager ID. But I'm still a technical manager. My job title is technical manager. So I want to go to Goa. Okay, so that's why you can't, in this scenario, yes, that's true, but you can't think about like this that the data will always be like that. Okay, you have to write a foolproof query. Okay, clear? So this was the example of union and union, union and union all. You can write union all and can check. It will give you a few redundant data probably. Okay, so union, union all, same way you can do intersect and okay, so what will intersect? I will not do intersect because it will not work, but think about it logically. If I do intersect, how many people it will return me? Or what is the logic? What will be the logic? Who we are taking to Goa if we use intersect? All the managers who are having man and manager in the job title as well as who are actually managing. So if my budget is low, I'll only take those people, I think 14 people. Okay, so intersect will serve a separate purpose and union will serve a separate purpose. There are ways of doing it using subqueries, so I'll tell you that when we'll do subqueries, but you know, believe me, my SQL is only for us to learn. Okay, this package is free of cost, but most of the companies where you go to work, they'll hardly use MySQL. They will buy a nice looking package for, you know, for a huge amount, and you will definitely work on DBMS, which are, you know, having all these facilities. No, Oracle is so expensive. It's the most expensive RDBMS. Yeah, the virtual boxes, you only have, you know, the front thing in it, and you can save your data. But when the companies go in production, think about Citibank. You know, they want to own the software. There are so many audit happens that you should own the software. There should properly backup, recovery. They can't use these freely available software. Imagine your bank using freely available softwares. Okay, so we can do the intersect using some complicated subqueries, but we need not to do it. You should know the meaning of intersect, and the tool will, whatever you are using in real life, will be able to do that. Okay, so that was about set operators. Yes.
Index of first table or second table?
First name, it doesn't matter, whatever the result comes. You can't take first name here because the names can be different in the one query and the other query. So always go by the numbers. In union, you have to go by the number. If it's an individual query, syntax error, I'll look at it later.
Here, what is the something self join is working? And m dot manager ID, I'm getting confused in that.
So look at this. So we are having this as m. Okay, this is m, this is e. Get manager information, I will look into this table. So I will do m dot employee ID and m dot first name and m dot first name. Okay, okay, people, come back again. No coding. We're gonna now entering into a territory which is a little scary. Okay, so I want your full attention. A difficult territory, so we're gonna put our whole focus on this. Subqueries, using query within a query. Okay, so I'll tell you how to write subqueries. You know, I'll teach you the syntax again, but I want you to focus on the thought process. So whenever we try to solve a problem, similar way, you know, writing a SQL, first spend 5 minutes thinking about what exactly we are trying to do. On a piece of paper, build a little blueprint of what the query should do or what tables we are touching without worrying about the syntax. That is the art that you need to learn. Syntax anybody can learn. Okay, so please focus on the thought process. Sit for 5 minutes, think what is this doing, what is this asking, this question is, and how will I be able to attempt. If you think it like that, your life will be very, very easy when you are handling subqueries. So we will do many examples and let's see how this will go. Okay, subquery is a query within a query. It's also called inner query or nested query. Also called sometimes the outer query is called parent query, inner query is called a child query, another name. Usually added in the where clause of the SQL, but can be in other clauses also. 90% of the time we use subquery in the where clause. But there are methods of putting a subquery in from clause also. We'll not focus on that, we'll focus on the where clause. Used when it is known how to search for a value using a select statement but do not know the exact value. What does it mean? We will see. Okay. Subqueries are an alternate way of returning data from multiple tables. So in SQL, if we are asking for some data, there is no one way of doing it that you need to remember. Okay. So you'll say that your answer is not matching with the other person, but the results are same, because there are multiple methods of doing the same thing in SQL. It's up to you which method to pick. So most of the things that we do with subqueries, we can do it by joining tables also. But again, why we use subqueries? Because the logic that subqueries use, it's the same logic as we think. Okay? We first find this is the step 1 of solving this problem. So for step 1, we'll write a subquery. This is a step 2. We will write now the main query. So this is how our thought process works. So subqueries are important so that our data is very much readable. Our code is very much readable. We can relate it to how we think about solving a problem. Okay. So how does this work? There is a main query. So let's look at this. Which employees have salaries greater than Smith's salary? That is the question that we need to answer. Okay. So what is the first thing that comes to your mind when you look at this question? What is Smith's salary? Okay. So what is Smith's salary? So if I can find what is Smith's salary, I can use that thing into to find out which employees have getting greater than Smith's salary. So what I'll do, I'll write a subquery for Smith's salary, and then I'll put that subquery in the where clause, and then write a main query, give me all the employees where it's more than Smith's salary. So let's try to write this query. Smith is just, I have taken a name, probably it's not in the database, so we will see. Okay, so what is Smith's salary? How will we find out? Tell me the code. Select salary from employees where, let's say Smith is the first name is equal to Smith. So this is our subquery. So what we'll do, I will put it in parenthesis, and what I want now, give me all the employees which have salaries greater than. So I will put salary greater than. Okay. Then what I'll put where here. Then I'll start putting select employee ID, whatever you want, first name, last name, from employees. If it returns null value, then the whole expression will become null and we will not get anything from the query. Yeah, but don't go into these things. Yeah, if this is the case, we have to do it. But let's just first try to understand the concept of subquery. Okay, so this should be our thought process. Going forward, whatever queries you will write, those will not be the simple one. Okay, those will be very complicated one, and your thought process should be trying to take one part of it, write a subquery, and then start building the main query or the other things on that query. Yeah, those are the things we'll do. But let's try to understand the thing. We will see if there are two Smiths, things like that. But okay, so probably to doing that, we have to probably create another clone of employees, and then try to fetch data from one clone. The query should be for Smiths. So there are some complicated way. If you want, I can write it during the break. But when the question comes, this is what comes to our mind, and we're going to code like that also. And it's not necessary that a query which is written in subquery will always can be written using joins. There are few, I'll give you an example, but this is the best scenario or best readable code that comes to mind when we have a question like that. Okay, clear about how to write subqueries? Okay, so few rules. The subquery, inner query execute before the main query. So what will happen here? This query will run first. It will return a value. That value will be stored in memory, and then this query will run that will use that value for this query. Okay, this is how internally it works. The result of the subquery is used by the main query to restrict the rows comparison operator. So you can use many things here. Less than, greater than, equal, not equal, any, all exists. So we will see about all of these. They are single row operators and the multiple row operators. So we'll see all of these. So list salaries of those employees who draw higher salary than Abel. So again, let's try to run this query. Abel is, I think, there in the database. Select employee ID, comma, first name, comma, last name. Actually, we will start with this. Select salary from employees where last name is equal to Abel. 11,000. Okay. Now, how will we use it? We will write where salary greater than. Okay. So, this is how we will a query can contain more than one subquery. A subquery can also contain another subquery. Okay, so you can nest it as many times as you want. No, if you put not equal to, salary not equal to, so it will give all the salaries except 11,000. You write that, write the logic first, write the query and then show it to me, then I'll answer that. Okay, so you can work with many permutation combination, put max here, but the logic should be to, the first thing should be what is the business question, then you start with what will be the query. So you give me a scenario, a business question that I want to find out the second highest salary, then I'll tell you what are the different ways of finding it. Should we use a subquery or should a simple query will work? Okay, so first think about what is a business question and then we will see how to run that. Okay, so we're gonna do many subqueries, so people please pay attention, not on coding, on understanding. List employees who have same job ID as employee this but draw higher salary than her. Don't worry, it looks very difficult while reading it. We'll do it step by step and it will not be difficult at the end of it. List employees who have same job ID as employee Nair. So let's focus on this. And I think Nair is a last name. Let's say I think it's a last name. List employees who have job IDs as employee Nair. So first what we have to find out? Job ID of Nair. Please tell me the, again don't code, concentrate here. Tell me the query. So we want all the employees whose job ID is same as this person. So what will we put here? And then select list employees. So I can write employee ID, first name, last name, and then I just also want to find out job ID, let's say, and from employee. Now we have done solve half of the problem. What is the other one? But draw higher salary than her. higher salary than her. So what will we first find out? Salary. Okay. So select salary from employees where last name is equal to Nair, and then higher than him, higher than her. So higher than salary, and I think we are good to go. And let's put yes. Comparison किससे करें? So we want to find out all employees who are satisfying this condition and who are satisfying this condition. So this condition is their job ID should be equal to something and their salary should be greater than something. So we want to find out all, this is a simple statement. If you remove this, let me put 100 here and let me put 10,000 here. It's doing the exact same thing. Select star from employees where job ID is equal to 100 and salary is greater than 10,000. It's a simple query that we have started with. But the only thing, before we used to hard code means job ID is equal to 100. Now we are making it something else, the runtime, any for a person. Let's say after a year, this person's salary changes. Let's say right now his salary is 12,000. Okay, so we could have hard coded it 12,000, but the benefit of putting a subquery is that let's say after a year her salary changes and now the logic will still remain good for my query. If I hard code it, we have to go back to program, check, okay, we have put the Nair salary somewhere in the code, now her salary has changed, let's change the code. Nobody will remember. It's the exact same query that we have written, the very first query, select star from employees where this, exact same. Huh? Not? Okay. What I'll suggest, you concentrate here. This you can work later. Okay, you're going to miss all of this. I'll definitely answer. I can stay late and answer your queries, but please people concentrate here. I know there are so many combination permutations going on in your mind. You will have enough time to do all of those things. But let's just try to focus here. Whatever I'm teaching, later on we'll do all of those things. And I'll not go home without answering each and every query of yours. No, we could have done if the salary is equal to her salary. Okay, if the question was who have same job ID and draw same salary as her. If that would have been the case, what we could have done, people? I could have done job ID, comma, salary, remove this, and then job ID, comma, salary, put it in parentheses, equal to this. So you can put multiple columns and can join with, compare it with the multiple columns of the subquery. But here the problem was one was greater, one was equal. So we could not do it. So and on the job you will get queries like this, not the simple queries that we were doing. Okay, probably more complicated than this. Okay, so this query can also be written using equivalent join version. So again we are doing a self join and then writing it like this. Okay, so to answer your query, what's your name? Nishima. So the same query we can do by doing self join. Remember the first query I also told you we can do it self join, but again somebody has to think about this logic and it looks so complicated. Self-join itself is very complicated. Okay, so that's why we go to, this is what our thought process is, step by step. Okay, and all odd subqueries can be converted into equivalent joint statements. So we'll definitely need subqueries. Okay, clear? Okay, let's do the next one. List departments whose minimum salary is more than the minimum salary of department 50. List departments whose minimum salary is more than the minimum salary of department 50. So what is the first thing that comes to your mind? Minimum salary of department 50. So select minimum salary from employees where department ID is equal to 50. List departments. So let's select department ID. If we want name, then we have to do inner join. Okay, we'll do inner join also. No, we'll see. होगा नहीं, चलो बस देखते हैं, ठीक है? Now what? The list departments whose minimum salary is more than this. Okay, so minimum salary is more than this. More than, then where, and then minimum salary. So now we have used minimum salary in our query. It's an aggregate function. So to get aggregate, to use aggregate function, what do we need? And we are doing the minimum salary of departments. So we will do group by salary. Grouping is which we are sorting it out. We are sorting it out on department and finding the minimum. Sorting out on department, finding the minimum salary. So group always on which group you want to sort to find the aggregate function. So it will be department ID. Group by, okay. So what we want to find out? We want to find out the minimum salary of all. So what is the logic? So what I want to find out? Department accounts, minimum salary 1000. Finance salary 1200. To first find out this list of all the departments, then I will check each salary with this minimum salary. If this is greater than this minimum salary, let's say for department 50, the minimum salary is 500. So I have this list, I have this number. So I will check this number with this. It's good to go. I'll print this. Let's say finance ki minimum salary is 200. I will compare it with the 500. It's not good to go. I'll not print it. And so on, do it for all the departments. Okay, yeah, that's a good question. We are using minimum salary. Okay, and I told you that you cannot use aggregate function in where clause. So what we do, we will having group by department ID. And then because we are using department name here, we have to do from department D join employee E, employees E, departments D on whatever it is. Let's try to write it out because this becomes a little complicated. So let's say if it runs or not. I'll change the font a little bit, it becomes difficult. Okay, so select minimum, you can also type in if you want with me, minimum, what is it? Minimum salary from employees where department ID is equal to 50, 2100. Okay, then I will put it in a bracket and then we will put having minimum salary greater than this query. Take care of the indentation also, it will make your query very much readable. Group by department ID. Okay, from employees. Let's say I will add department name later. Okay, select department ID, comma, minimum salary. Okay, so I'll run it. So these are all the departments who are having salary more than 2100. Was that the number? Not 2100. So their minimum salary is more than 2100. So let's say I want to print the department name also. Department name, comma, employees join E, join departments D on E dot department ID is equal to D dot department ID, and I have to prefix department ID E dot department ID. Okay, and run it again, and now it gives me all these departments. Okay, null was coming before, but when you join it with the another table, null will be gone. So this is actually you write your queries in real life. You start from one thing, then you build on it. Is this clear, this subquery? Yes. Yes, because this will give the same result as that one, because department ID and department name is there is a one-to-one relationship, but you can give, there is no problem. Try to give it so that later on if there is any issue, but there will not be issue because department ID is a primary key, but still that's the best practice to give that also. It will say return the same result. So you can put the subquery in where clause, also in having clause. Okay, So let's look at this query. Okay, people, stop coding. I'll give you the presentation, do it later. Let's look at the last query and you're going to tell me what is wrong with it. Select employee ID, last name from employees where salary is equal to, so we want to find out all the employees who are earning the minimum salary in each department. We want to find out those employees who are earning minimum in their departments. So what is the business logic? We want to find out who we are paying the less. Probably they have more tendency to leave if they come to know that they are getting the least salary. So my manager wants a list of all the employees department wise who are earning the minimum salary in that department. So that is written, select minimum salary from employees, group by department ID. No, that is not the problem. So what do you think? There are 10 departments. How many rows this query will return? 10. And what we are doing? We are only comparing one salary with equal to 10 things. Is that possible? So what operator we will use if we want to see? So the problem with this is that you have to use in here. So we can use equal to is only when one-to-one comparison. Otherwise for multi-row thing, you have to use in, you have to use any, all and exists. Okay, so if we write in here, they will give us those people who are earning the minimum. Okay, so let's try this one. Again, people, all eyes here. Okay, if I run it, it will give an error. Subquery returns more than one row. I will change it to in. And these are the poor people who are getting the minimum salary. So in 90 department, these two people are earning the minimum salary. And their salary is 17,000. Yeah, you're right. Okay, so we will do another query to do the exact same thing because we have to now match the department also. Okay, very good observation. So we'll talk. But right now, just understand the in operation. What does in does? If there is a list given by the subquery, it will check everything in that list. But very good observation, and we'll handle that situation when we'll talk about correlated subquery. Okay, so this is just some theory. There are equal to, greater than, all these operations that you can, all these operators that you can use. In, not in, any and all will be used when the subquery returns multiple values. Okay, so let's try this one more. List employees who work in countries other than US and UK. So think about it, how will we do it? List employees who work in countries other than US and UK. So I'm going to build the query here only, okay? So you're going to help me. Select country ID from, let's say, countries where country ID not in US, UK. Let's run it. So this is I don't know, Berlin, Czechoslovakia, Denmark, Czech Republic. So there are many countries. So we want to find out the employees who are not working in US or UK. So how will we find employees? So we have in the country table. So how many tables we need to traverse? We are in country. From country to locations. From locations to, from department to employees. Okay, so select employee ID, comma, first name, comma, last name, from employees, E, join departments, D, on E dot employee ID is equal to D dot department ID. Okay, and inner, no inner, join what? Locations on L dot location ID. Is it locations or location? Huh? सही है, सही है. Is equal to okay, and then we don't need country. Okay, we don't need country because location has country in it. Okay, so where country ID in. Okay, so these are the three people who are working in Canada. Two are working in Canada, one is working in Denmark. Everybody else is working either in US or in UK. Okay, so this is how step by step you build your query. Oh, they have not joined country table. It's okay. We could have done it the other way. Instead of using country ID from countries, we could have used it from location only. Okay, so go through this query also. It's doing exactly the same thing. I'm not printing here. So I'm putting in and in twice. So what is happening? Let's look at this. We are finding out all the location ID where country ID is not in US, UK. And then I am putting that in, creating another subquery and getting the department ID, and then creating another query where the department ID in. So as I told you, same thing can be done many ways. So here we are writing subquery within a subquery. Okay, so let's do it one more time. Okay, select locations ID. Where is it? Locations where from locations where country ID in not in US, UK. So what it will give me? It will give me, I need not to go to countries table because countries table has country name. I can go with the ID only. So this will not, countries table is not required. So, so let's now find out what are the departments and this location ID. So I will write where location ID in this, and I am looking for the results. What are the departments? So we can do it this way also, from departments, okay, and then select department ID from department. So this is, again, I am finding out, instead of joining together, I am doing it step by step. Okay, first I found all the location ID. So if you look at this one, what I am doing, for the US or UK, not US or UK, I am finding location IDs. From this location IDs, I am finding all the department IDs, and from this I am looking for, give me all the employees who are in these departments. Okay, so now we have come up with department ID. Now we will look at where department ID in, select department ID, okay, and then I will write from employees, select employee. What is the problem with this query? The problem is you cannot find department name here or the country name here. Only the employee ID and then first name. Okay, I've done something wrong. So this is for this, and this is for this, and this is. Okay, again the 3 rows returned. But the problem with this query is that you cannot find country ID here. Okay, but there are, again, I'm telling you, there are different ways of doing the same thing. Okay. Okay, so we're gonna make this good again today. Lot of revision today, lots of hands-on exercises. I have prepared a mixed worksheet for you. With the very simple commands first, and then as you move along, the complexity will increase a little bit, as we have done. First we did a simple select statements coming from one table, then we did how to join 2 tables, then we did how to apply the functions, single row function and multi-row function, then we did how to do subqueries and subqueries, union, all those things. So we're going to revise all of those today. But first of all, any query from whatever we have covered till now, we have done quizzes, 3 quizzes, 3 in class that WCP exercises and 3 take-home exercises. And along with that, the 3 worksheets that I have given you. So in all of these, is there any query and you feel, if you felt struggled working with some query, any question, any quiz question, feel free to ask. We will first clear those things and then we'll move. What kind of query is best used to create a report listing customer, first customer, including their associated purchase order? How many purchase order, how many orders you have placed? Like you go on Flipkart, you have purchased 10 orders there, right? So what I want to do all the customers and their I will join it with the order table, and then I'll get for this person how many orders are placed. Okay, so the right answer will be a query with an outer join. So even if the person has not placed any order, I still want to see that customer information. Okay, it's best to create a report listing customers by zip code and including their associated purchase order numbers if they have made any orders. If they have made any orders, then I will want to see their orders. If they have not made any order, still I want to see the customers. How many customers are there? Okay, so it means that we want to give priority to customer table. It means we have to do outer join on the customer table, so that even if the person has not placed an order in on my website, still I want to see that customer. So say which query contains a syntax error. You can probably cut paste it, put it in the workbench and then indent it, and then it will be better for you to understand it. Like these are very big queries. Has anybody done this one? So the best way is to take this in the SQL workbench. Okay. You don't have? It doesn't matter you have database or not. It's just gonna put it in blue and black color in coding just to see that is there any syntax error or not. Okay, it doesn't matter the data is there or we're not gonna run it. I'm just putting it there for the better readability purpose. So like this query looks okay to me. Without even running it, we are just doing a select statement where product ID, and we are writing some subquery in it, and we are matching the product ID here. And then let's do this one. Let's cut paste this one. This also look good to me. What we are doing, we are just doing where this two things is in this two things. So here is also a pair, here is also a pair. So I think it looks okay to me. Yes, it will work. I don't think there is any syntax error in it. The syntax error will come. Okay, we have seen the second one. So this also look good to me. Let's see the third one. You will see a glaring problem. Okay. So the third one. So without even worrying about are there tables, what are the tables, if you look at it, just the structure of this query, can you see any error in it, like logic wise? That should not be a problem. We can use the where clause so this is the where clause of this main query, and this is the okay, so group by is also there. So that's fine. We have done many queries which are having where and group by. Remember we did it yesterday? There is something else wrong here. That should also not be a problem. I can do group by department ID and I can do order by department ID. Not a problem. I want you to look at this thing and tell me what is the problem. Yes, the problem is, what are we comparing? We are comparing this column with the output of this query. How many columns are here? Only one, created by user. And how many columns here? Two. Okay, even if we are using in requires a list, but we'll never be able to compare one column with two columns. How will SQL work? Okay, remember in this query, we are comparing this pair. So this column will be compared with this one, this column will be compared with this one. Okay, but here we are only comparing one column with two columns. So that is the problem. Okay, so try to cut paste in the MySQL workbench, try to indent it and then see what is the problem with the queries. Can we use reverse keyword? I don't know, I will, no, I don't reverse, let me check. You know, they are coming up with new functions, so I just want to check they have done anything in it. Reverse in MySQL.
Reverse is just like upper
Huh.
and lower.
So what does reverse do? If I give reverse ABC, it's gonna give me CAB. So select reverse. No, it's a function. So reverse is a single row function. So if I give it any string, it's gonna reverse it. Okay, so if I write first name, comma, reverse of first name from employees. Okay, so I have to. So you'll see it is reversing the string. It has nothing to do with sorting. We are not reversing the sort. That's order by descending. Here we are just simply using as a, like we use, you know, upper, low, uppercase, lowercase. Similarly, we can use the reverse function. Anything else in the quiz? Anything you're struggling with? Yes. Question number 5, which one? In the quiz. Just check whether the sequence is same or not. Sometimes the sequence of questions is different. So question number 5. Is this one? Okay. Use the table for all the quizzes below. So this is the table that they have given. So this is some game table. There is some ID of that game. Then I think on which day it was played. Okay. This is the date. And then in which stadium. And what was the team one? I think these are football matches. So Poland and Germany. I don't know. Okay. So this is the data that we have given. And then there are goals. So in this match, ID is 1001. In this match, this team and this player has, I think, game time, the time of the game. The time of the game that player has played. Is it like that? Achha. Okay, when the goal was scored. Okay, so the goal time by this person. So in this match, there were 3 goals, happened, and the 17th minute, 51st minute, and the 82nd minute, and these are the players who have done that goal. And then what is this? This is the coach of the team. So Poland team, the coach is this, and the coaches are this. It's Greece. Okay. You want to find the stadium where player this. Okay. So you want to find the stadium where player this has played probably, right? So where is the player? Player is this, and this is the stadium. Okay. So we have to join which tables? Game and goal. And on which key? We will join it on the ID key. Right? So if you look at this, Ajanta has played in 1001 and the name of the stadium is National Stadium. Okay? So we're going to join these 2 tables, game and goal. So game and goal, this is the one. on match ID. So the D is the answer. Why not? Team ID. But first of all, it's the E team and goal. Sixth also. Okay. Who you join the tables goal and E team. So goal has who has done a goal at what time, and E team is the coach, right? So you join the tables goal and E team in the SQL statement, indicate the list of column names that may be selected in the select line. It's very easy. So what is the goals, what are the columns for this? Match, match ID, team ID, player, goal time. Got it? Okay. Select the code which shows players, their team, and the amount of goals they scored against Greece. Okay. So let's try this one. It's again difficult to read from this. Let's try to move it to the SQL workbench, and let's then see if we are able to find it, what it exactly it is doing. Do you think indentation make a difference while reading the query? Okay. So what we are doing, we want to find out the team who has played against Greece and how many goals they have scored, which shows players, their team, and the amount of goals they scored against Greece. So how will we find out? Let's look at it. So we do not need E team. Do you think we need E team table? Because E team is only giving us the coach name. So we don't need this one. So this one is out of the contest. So let's say we are looking for game and goal. And game and goal we want to find out against Greece. So what we want always either team 1 is equal to Greece or team 2 is equal to Greece, right? Only then the Greece has played that match. Okay, so in the where condition we want team 1 is equal to Greece or team 2 is equal to Greece. This is the one filtration we want. And then now let's look at it. Which player has made a goal against in that match? So we will join both the tables, game and goal. So from game, join goal on, what is the common key? On GA dot game में क्या है? ID is equal to goal में क्या है? Match ID. Okay, so this will give us the combination of everything, and then we have filter it on how many only the games where Greece has played, and then we will want to find out for those matches what were the players. Okay, so you can select player. Okay, what was the question? Select the which show players, their team, and the amount of goals they scored against Greece. Player, so we have player, and then what we want? We want their team. Okay, so there are two teams. Okay, but we can select the player from the goal table, I think, right? So team there. Okay, so this again we have to pick the team ID from here, from goal. Okay, team ID from goal. And then we want number of goals. So we have to do, how will we find number of goals? We have to do count. Count of, we can put, is there a goal? Goal time we can put, right? Count of goal time. And then on what thing we have to group by? So they are saying player has made how many goals, which shows players, their team, and the amount of goals they scored against Greece. Okay, so group by player, and we do not want those goals which have been scored by whom? By the Greece team. We only want the goals which have done against Greece. Okay, so we have to put one more filter here. Where the team ID of goal, okay, where the team ID of goal is not equal to Greece. Okay, because we only want those players who have done a goal against Greece, not by the player of Greece. So we will exclude not equal to Greece. Okay, so our query should look similar to this one. So now let's look at the queries. The best way to do it okay, so let's look at this one. This is the first one. What is the problem here? The first query. Look at it and tell me. Compare it with this one. I think we got the jackpot. Even the first query is, I think, the correct. But let's look at the second one. We just want to be sure that we have picked up the right one. So let's look at the second one. What is the problem in this? Team 1 is Greece. What happened if team 2 was Greece, team 1 was Poland, and team 2 was Greece? Still the match was played with Greece, right? And we are not counting those goals. Okay, are you able to see? Team 1 is equal to Greece. It doesn't say team 2 can also be Greece. So it will not pick all the matches that have been played by Greece. So there is a problem with this. So this can't be the answer. Let's just pick the third one also just to see. ये तो बिल्कुल ही गलत हो गया. कैसे? ये तो बिल्कुल ही गलत हो गया. Why? We are looking for Poland matches, not of Greece matches. So outrightly this is wrong. So pick up the first option. I think that is the correct one. But this is how you solve it, right? It's not only looking at it. You have to think. You have to spend time, do step-by-step thing, and then you will get the answer. Anything else in quiz? Because they have not created the foreign keys. Okay, so it's okay. You just look at it, and we will be able to see that how the tables are related to each other. Okay, so I have done the same thing. Okay, so even if the foreign keys are not there, so let's look at it. This is my main product table where we are storing all the products, and this is the product class code. So there is a product class code here. So this looks like the list of all the product class, and we are having, this is the primary key, and looks like there is a foreign key relationship here. Okay, so this is how you go about it. If the foreign keys are not given, based upon your domain knowledge, you figure it out, probably there is a connection there. And when you will join these two tables on product class code. So let's try to understand this. We are selling things on internet. Let's say we have Flipkart or any Amazon, any company. So we have a table that has all of our products, product ID, product description, product class code. Class code can be, is it an appliance, is it a grocery, that can be the class code of the product. Product price, product quantity available, length. Okay, probably the product's length, how big or how small it is, length, width, height, and then weight. Okay, so these are the information that I have on my product. Okay, and then I place an order. Okay, I have customer. So customer is this information, online customer, his customer ID, name, first name, last name, email, phone number, customer creation date, username, customer gender, all of these things are here. Okay, so can you tell me, customer gender is care, but customer name is where-care. Why is that? So they are only defined it care 1. It means it's M or F, and it's fixed, so that's why they have defined it as care. So this is my online customer, and there must be a table somewhere which join my customer and my product. Can you tell me which is that? Which one is that table? Customer places an order, right? We place an order on a website. So which is the table which connects the customer with the product? No, name. There is only one table that connects both online customer and product. Product has a master table which is product. Online customer has a master table which is online customers. But there must be, when we purchase order, there must be a table where we are storing this customer has purchased this product. This customer. So that column, which one you said? No, I don't think it's order. Order header. Do we have product in it? Or probably yes, I think. Yes. No, still no. Customer ID. Where is the product? So order ID. So actually it's not one table, it is actually two tables. So what is happening? Then there is an entity called order. Okay, and order can have many products in it. Let's say I ordered 5 products in one order on Flipkart. I ordered a mobile phone, let's say a laptop. I ordered 5 things in it. So there will be one order created for me. So that order will be in the order header. So order ID, today I have created it. This is my customer ID. This is the order date, order status, it's pending, shipped, payment mode, payment date. Okay, so customer is connected to, so where is there is a foreign key between, so where is the connection? Order header has order ID as a primary key, but what is its foreign key? Customer ID is the foreign key, which is connected to this table. Okay, now this is my order header. Now I want to find out what items I have ordered in this particular order ID. Okay, and that connection is where? That connection is in order items. How many items I have ordered in this particular order number? And I will have 5 rows. I will have 1 row in order header. I will have probably 5 rows in order items if I have purchased 5 products in that order. Okay, so what is the primary key of order items? Primary key is order ID and product ID. So for order number 100, I have purchased product ID P1, 100, P2, 100, P3, 100, P4 and so on. When we have 2 columns as primary key, what do we call them? Composite primary key. And this primary key is also foreign key. Okay, so order ID is a foreign key coming from this table and product ID is a foreign key coming from this table. Are you people getting what are we talking about, how this thing is? Because it's very important to understand this. If you don't understand this, you'll not be able to join tables properly and get the required data. Even if the foreign keys are not given, it's okay. Based upon our knowledge, we can figure it out how these tables are connected to each other. Okay, so order items, this table is done. We understood this, this, and let's now say, and this also. And then the address. Okay, so where is the address used? Yeah, here it is. So what we are doing, customer can have many addresses, right? Even when you order, it's an office address, it's a home address. Okay, so this is my master table, this is the child table. So one customer can have many addresses. Okay, so customer and address. I think no, this one is simpler one. It can only have one address because address ID is inside the customer table. So one customer can have only one address according to this database. So address ID is a foreign key here and it is connected to the address ID primary key there. Okay everyone? Okay, and then, so this is also done. Then we have 2 more tables. Let's understand that. Carton and shipper. So when we carton and shipper. So, carton I think will be connected to this. There is no carton ID. Let me see. Here it is connected. Okay, So shipper ID is here. So every order that we place, there is a shipper ID attached to it, which says what is the shipper name, shipper phone number and shipper address. And then I think there is also the carton ID has not been used anywhere. No? It's okay. There is a table, probably they forgot to, they created it to be used later. We will see how we can use while doing these take-home exercises. Did you ever use carton table? Was there any exercise query to use carton? No? Okay. So we'll say this is just some table there we will use. But we understood everything else, didn't we? So the best way to deal with this type of database, get a copy, print it, and then probably manually create the foreign keys, the relationships, the lines, and put it in front of you, and then it will help you to write all the queries. Okay? No, this one is just to collapse it and then open it and close it. This is for this. Oh, this one? This is a non-key, I think, and this is the key. Remember we talked about key attributes and non-key attributes. So the yellow one are primary key and the simple one are the normal keys. And when there are some, I think, blue color also, right, on some, I think those are probably the non-null, not null. So that's why there are some blue bullets. Some are blue, some are not. Right? Can you see the blue and not blue? Right? So probably these are the not null keys. Okay, now we have understood our database. Now we can start writing queries. So which query? People have many questions in the take home exercises. Okay, first take home 2. Let's do day 2 first. Those are simpler one, then we'll go to day 3. Am I right? Okay. Okay, which one? 6. 6 is तो हमारे HR से ही है. Okay, so we'll do it. What is the average salary range? So now when you're saying average salary range, it doesn't mean that we're gonna take an average. Okay, what does it mean? They have explained average doesn't mean average, it means difference between min and max salary of all types, managers and clerks. So only where the job title has manager or clerk, we want to find out the difference between min and max salary. So let's look at the ER diagram. Okay, so where are the job titles? Job titles are in the jobs table. And what is the min salary and max salary? We need not to use the aggregate function. Actually, they are talking about the columns which are named min salary and max salary. Okay, and we want to find their difference, and difference only for titles which are having manager or clerk in it. Okay, so how will we write this query? Select max salary minus min salary as difference from jobs. So that is the, I will just simply write one query here, and then I'll also type job title. So first build the simple query, then we will add where clause, order by clause, all other things. Okay, they have asked for only for job titles which are manager and clerks. So we don't want testing I have added. We don't want public accountant, we don't want administrator, assistant. We only want people who are having who are managers and clerks. So we will add a where clause, job title like manager or job title like clerk. So we will only get managers and clerks. So see, accounting manager, finance manager, marketing, purchasing clerk, and so on. So if you see, sales manager is the one who are having the maximum range. Means you can hire a sales manager on a low salary also and on a very high salary also. So the difference between min and max is the maximum. I'm sorry, 2 rows? It's okay, you know, I'll check and make sure that I think I added more data. We have added more data later. So that is the reason why. Yeah, or probably they have interpreted it as clerk and there is no clerk and manager as such. No. So this is fine. 9 rows. Write a query to show the count of cities in all countries other than this with more than one city in the descending order of country ID. So whenever something like this comes, it is very, very confusing. Okay. So what is the method of solving this type of problem? Do not even look at the rest of the thing, only look at the first few words. Write a query to show the count of cities in all countries. Stop. Okay, count of cities in all countries. So how do you think we'll solve this problem? We want to find the count of cities and we want to show the countries. Okay, so let's start building this one. Select, let's say, country ID, comma, count of cities. And from the ER diagram, we know that country ID and cities are in the same table. What is the name of the table? Locations. Okay, so country ID, count of, is it cities or city? From locations. Let me just run it. This is what I did not expect. I wanted to find out हर एक country में how many cities are there. Okay, what did I do wrong here? Or what did I miss here? So yeah, so the count is fine. There are 23 cities, but the country ID, it has not given me by country ID. So remember that picture, we have to group on country, find the number of cities, group on country, find the number of cities. Okay, so even if this is giving me data, this is not correct data. So you have to think and then add, because we want to do country wise number of cities. So we will add group by country ID. So Australia has one, Britain had one, Canada has one, I don't know, CHS, Czechoslovakia has 2. DBMS. After this. Where is the error? Let me see, तुम थोड़ा font increase करो, आपकी eyesight weak हो जाएगी. कौन सा schema यही है? Show me the table. Locations में देखो city है. Columns. City and location. Country ID है. Country ID. Select country ID, comma, count of city. Oh, ये आपने space 2 बार क्यों locations डाल दिया?
वो अभी select किया ना.
ओहो, अच्छा ठीक है. ठीक है, run करो. Integrate function without, हाँ ये अब आपके मैक में ना नया ये वर्जन है एसक्यूएल का, वो रन ही नहीं करेगा क्वेरी. अब उन्होंने और चेक लगा दिए हैं ताकि जब तक कि आप ग्रुप बाय नहीं डालते. सो विच इज अ गुड थिंग प्रोबेबली. हो गया. वी आर नॉट डन, वी आर ओनली सॉल्व द फर्स्ट पार्ट ऑफ द क्वेरी. शो द काउंट ऑफ सिटीज इन ऑल कंट्रीज. नाउ लेट्स रीड अहेड. अदर देन यूएस एंड यूके. So what do I have to do? Need to do now? Other than US and UK. So we don't want US. We do not want UK. Okay. So where should we put the condition filtration? In the where clause or in the having clause? Okay. Please remember, having should only have filtration if it's a filtration on aggregate function. The filtration is not on aggregate function. What is the aggregate function here? Aggregate function is count of city. If there is a filtration of count of city, we will put it in the having clause. It is a filtration of country and on the raw data. Means we do not want those rows from the locations table where the name of the countries are US or UK. So please remember this concept. Okay. What happened? When there is a filtration of count, only then we will put it in having. If there is a filtration or any other column, we will put it in the where clause. So we will put it where country ID not in US, UK. So right now it is showing me 14 rows and I can see US and UK 3 and 4, but if I run now, it will not, only return 12 rows and US and UK are not returned. Okay. Again, we are not done with it. Let's look at the query again. With more than one city. अब इसका क्या मतलब? With more than one city. हाँ, we want the count to be more than one city. So we want a filtration now on count. Now where will we put it? In having. Okay. So we will write having count of city greater than 1. So now 12 rows return. So all the 2's will, only the 2's will be left, 1 will be gone. Canada, Czechoslovakia, Italy, Japan. Yes. Yes. No. You can either write it country ID not in US, comma UK, or you can write country ID not equal to US or country ID not equal to UK. Like will not come. Why will we use like? We know exactly it's US and UK. Like will make our query very, very slow. Okay, so the last thing is now they want to sort it in some manner. What is that? this is descending order of country ID. Okay, so which is pretty easy. So we'll do order by country ID and then descending. So Japan will come first, then Italy, then Czechoslovakia, then Canada. So you should learn not only the syntax, also learn the process of doing problem solving, step by step, line by line. No, we are posing a condition on the country ID. Okay, and country ID we have done a grouping on it, but having made what will happen, only the things which are aggregated, okay, either count, sum, min, max, only that thing will go in having. For everything else, for all other simple columns, the filtration will go in the where clause. Only when the filtration is on aggregate function. What is the aggregate function here? Count, not by group by. You have to think it like whenever the filtration is on the aggregate function, and there are only 5 aggregate functions: count, min, max, sum, average. If there is a filtration on these 5 things, that will go in having, otherwise it will come in the where clause. So there is a fixed sequence of commands in SQL. The first one is select, second is from, third is where, fourth is group by, fifth is having, and sixth is order by. And limit always come at the end, that is the after order by. You cannot change the sequence of this. It will not work. Okay, the sequence is here only. The number 1 is select, second one is from, third one is where, fourth is group by, fifth is having, sixth is order by, seventh is limit. Take home, this is not take home? Yes. Display all departments' name, the city where they are located, along with the manager name of the departments. Again, we will only look at the few words. Display all department names, the city where these are located. Okay, so all department name and in the cities they are located. So which 2 tables we have to join? यही query थी, ठीक. Next one, which one? Take home exercise 2, question number 10. Okay, write a query to display details of customer who have Gmail account and phone number consist of 77. How will you write consist of 77? Like percentage 77 percentage. Okay, like percentage 77%. We did a similar query, find for names which are having in it. Similar way. ठीक है. What else? Okay. You have to join manager ID of department is equal to employee ID of employee to get manager name. Department में एक manager ID है ना, we want to find out that manager's name. So that manager is also an employee. Okay, so we will join that manager ID with the employee table and we will write D dot manager ID is equal to E dot employee ID and get the first name, last name. What else? Take home 3. ये लिख लिया सबने? We done with this one? Okay. Take home 3. Which question? First also? Okay, write a query to display the product details. Product class code, product ID, description as per the following criteria and sort them in descending order of category. Okay, so that we will do. If a category is this, increase the price by this. Okay, so first of all, let's say which table we have to hit, product details. So it's gonna be, where are my product details? Product details are here. So we have to do select from product. So in order to run this query, I'm going to make my order schema active. So I'm going to double click on it. If it is highlighted, it means it has made my order schema active. So select, what has he done? He has asked, so let me just cut paste from here only. So I want to display product class code, product ID, product description, product price from product. So this is my simple query that I will write first. Now they are telling me something else, that create one more column which is as per this. If the product class code is 2050, increase the price by 2000, 2051, increase the price by this, and so on. So when we have if then else statement, we use the if function. When we have more than 2 if then else, if then else if then, what we use? Case. So we're going to use the case statement here. Okay, so I'm going to write another column. So comma, please do not forget the comma. We are adding another column, case and product class code. So whenever the product class code, if it is equal to 2050, if the product class code, if it is 2050, I can also write case if product class code is equal to 2050. Both way will work. If it is that, then what I want to return? I want to add something, right? Increase the price by 2000. So I want product price plus 2000. If the product class code is 2051, Increase it by what? If it is 2052. Oh, I'm sorry, you can't use if. I'm sorry. It is when. I got confused with if. And if there is nothing like that, else what we want? We want the same product price. So do not forget else statement also. And also, we need and also. That is the syntax. Okay, I'll give it a nice name, new price, and run it. So we need to sort also, because they have asked us to sort on something. Sort them in descending order of category. So order by category. What is category? Is there a product category? No, it's a product class code only. What else? Third. Second also. लिख लिया ये सबने? Write a query to display the product description, product class description, and product price of all products which are shipped. Okay, so we have to use these 4 tables. Why? Because we want product description. I think product description is in the table product. Product class description is in the table product class. Product price is in product table of all products which are shipped. And I think shipped is in order items and order header. So let's look at the ER diagram. So we want product class description, product description, product price. So these are the 3 things that we need, but we want only for orders which are shipped. Okay, so products shipped is from the order. So we have to join this product with the order header. Okay, and then from the order header we will get a order status which is shipped. And why we have to join it with order items? Was there anything here? Product price which are shipped. नहीं, product ID क्यों चाहिए? Product ID तो product table में ही है. ओ हाँ, प्रोडक्ट, क्योंकि प्रोडक्ट आईडी और ऑर्डर आईडी यहाँ लिंक होते हैं, फिर शिफ्ट जो है वो यहाँ जाता है. Okay, so that's why we have to join 4 tables. Okay, so let's quickly do that. Select, let's first join tables from products, product, join product class on P and PC. On P dot product class code is equal to PC dot Okay, now I'm going to tell you one more thing. Now we know how to join tables. So there is one more method of joining table. When we know that the column, there is a column, common column there in the two tables. So product class code and product class code here. There is one more method which you can use. So people pay attention, look how I'm doing it. So instead of writing these two lines, I will just simply write this line. Natural join and get rid of this thing. When we say natural join, what SQL thinks? Natural means the same key is in this table and then the same key is in this table. Whatever common key it finds, it automatically joins. No, again one by one, that the way I told you, not like natural join this, natural join, Yes, only when the keys are same, the column name is same, column name needs to be same. If it's different, you can't use natural join. Only when the column names are same. Remember when we were doing d.manager id is equal to e.employee id, there we can't use it because the column names are different. But when we are doing e.department id is equal to d.department id, there we can use it. Okay, so let's try this one. Okay, and let's p dot product id comma p dot product description comma pc dot product class description. Okay, then natural join. Now let's see if there is a common key. So product ID and the product ID in order items. So there is a common key, I can do natural join. Okay, so what was the question? The question was write a query to display the product description, product class description and product price. What is the product price? Where is the product price? In the product table only, I think. So let me change this a little bit. So let me do o.oi.order id. So for this order, they have placed how many products? 1, 2, 3, 4, 5, 4 items they have placed in the first order. One was the TV, one was the infant sleepwear, Samsung Galaxy and foldable premium chair. And this was the product price. And so what else was saying? We only want to see where the products are shipped. Okay, so let me show the ship also. What is shipping? That is the order status, right? And that is in the OI table, order items table, I think. No, order status in order header, sorry. Okay, so shipped, but there must be few which were not shipped, in process. We don't want the products which are in process. Okay, so we want to get rid of those. So we will just put a filter where order status is equal to shipped. Okay, so before there were 205 rows, only now 168 rows. And what else? Order which are shipped, that's it. So this is my query. Okay, I'm going to do third also. Should we do third and then take a break? Okay, so natural join, I told you, normally how we'll do? Normally we will use the simple inner join, right? So we want to find out, select first name, last name, department name. So because we want department name, we want to join employee table with the department table. So this is how I taught you to write. On E dot department ID is equal to D dot department ID. Initially we should start with this. This is the logic, okay? And it is possible that sometimes we do E dot employee ID is equal to something else dot manager ID. When the column names are different, when the column names are same, we can use natural join, but when the column names of joining are different, then we cannot use natural join. Because here the column names are same, we can replace these two lines with this line. From emp E, you can give alias, you can't give alias, it's up to you. Natural join department D, and you don't need to give on what, because natural join automatically thinks that there is some common column between the two tables. It automatically pick department ID from employee, department ID from department, and join. So like in this example, if I write on, the query becomes a little complicated. Okay, so we can use lengthy also, so we can use natural join, but you have to be 100% confident that the name of the columns in those two tables are exactly same. Only then natural join will work. There should be only one column, there can't be two columns. If two columns, again it will get confused. Okay, so only one common column. Okay, we'll do the third one, then we'll go for a break. Then don't use natural join, go by simple join and tell it on which column you want to join. Okay, the third one. Write a query to display the customer ID, customer name, email and order details, and they have given the order details, subtotal, product quantity into product price for all customer even if they have not ordered any item. Okay? So what do you think, even if they have not ordered any item? Okay, so customer places order. So online customer and the order header. These are the two tables which has information about what order I have placed. Okay, so when I join these two tables, let's say there is a customer who has not placed an order yet. I have joined Flipkart today only. I have not placed any order. But the Flipkart CEO wants to find out the list of all of its customers. Even if they have placed an order, tell me the order detail. If they have not placed an order, still I want to see those customers which are there, which have signed in on my website. Okay. If I do simple join here, inner join, order header and online customer, you think you will get the customer which have not placed an order? No, you will not get it, because inner join means only when I have the customer ID here in the order header, because I'm joining, it will only join it will give me the common things. Customers who have placed an order, only those one. He is saying, give me the customers who have not placed an order. Give me those customers also. So what will we do? We will do, if we keeping the customer table on the left hand side, we will place an left outer join. Okay, let's quickly build this one. This looks like a complicated one, but I'm telling you step by step, if we do it, it's not that difficult. So let's just first select this. Customer ID, customer name, email. Select customer ID, customer name, email from online customer. Okay. Customer, okay, so let's concat customer F name, customer L name, and call it full name. Customer email. Everybody okay till now? Just customer information. Now I want his order information. So order details, I want this information. Order ID, product description, product quantity. Okay, let me see the order one. Order header. Order ID, comma, what else? Product description, that we don't have. Okay, so let me first join this on product quantity also they want. So should we join it on, okay, so we have to join it on that. Online customer, natural join, order header. Right? So online customer, natural join, order header. It will join it on customer ID. Then order header, natural join with order items, that will join it on order ID. This is customer, this is order header, and this is order items. Okay, I have to give customer ID C dot, otherwise it will complain, and order ID I'll also do OH dot, and let's try to run this one. So we are getting some data, and then we want from the order items product ID, product quantity, and I also want product description, right? So for that I have to again do natural join with the table product, and then I'll go into product table and then product description. Okay, product ID is in many, so let's do p dot product ID. Let's run this one. Oh, product. So this person has placed an order. This is the product ID, this is the product description, and these are the number of products he has ordered. Everybody getting it right? Okay, what else? So we have done with customer ID, customer name, email, order ID, product description, product quantity. Okay, so let's try now product quantity into product price. Subtotal. Subtotal we'll do later. Let's just first find out this column. Okay, so product quantity into product price, and then this is okay, product quantity price in P only, and we want it subtotal. Subtotal means sum. Okay, subtotal based on what? Let's see. For all customer, even if they have not ordered any item. So let's do group by customer. For all subtotal. Okay. Oh, actually it's not sum. Let's not do sum. Okay, so this is the product quantity and this is the product price, and we are doing a multiplication of both in order to get okay, because the person has ordered 3 infant seats, it has given me 250 multiplied by 3, $750 for the product quantity into product price. So subtotal doesn't mean subtotal, it means that we are doing a subtotal by doing product quantity into product price. Okay, and then they are saying even if they have not ordered any item. So you will see here people only who has placed an order. Let's say there are a few people, 205 rows, they have not placed an order yet. So what we'll do, we cannot do the natural join here. So we have to do here full, not full, left outer join. So before there were 205 rows, let's see what we get now. Left outer join, because customer is on the left hand side. What? Oh, we have to give it, sorry, on C dot customer ID is equal to OH dot customer ID. So before there were 205 now, so there are no customer here, but if there are a customer, so let me quickly create, just I want to show it to you. So insert into customer, online customer, and customer ID, comma. I'm just trying to create a dummy customer. Customer F name, and I think customer gender. These are the three mandatory columns, so I'm just creating those. Values 9999, let's say Reena, and then so I have added one row, dummy row. So when I now run it, there will be 200, still there is 205 rows. I think once you put a left outer join, let me just, don't you do make any changes, let me just try it. I think you have to put left outer join on everything. On OI है, OI में है product ID. Oh, now I got it. Still no. Oh, I'm displaying full name and customer email. So 9999 is there. Okay, but because the other one is null, it has made the whole thing null. Are you getting what I'm saying? So hold on, let me enter one more thing. So let's make it 1111 Sameer Arora male, and then customer last name. Okay, and run it. 227 rows and Sameer. So Sameer has not placed an order, but still you are able to see it. Why you were not able to see my record? Anybody, any idea? Because I did not give my last name. So when I place full name, so Reena plus null, it has made everything null. So it was showing my ID 9999, but it was not showing my name. Okay, so that's why I could not find my name, but 9999 was there. Okay, so let's look at the query now. So what we learned from this, that if you are doing left outer join, you have to do left outer join on all the things. Okay, you have to do left, you cannot do left outer join and natural join. It will remove those extra records. So you have to, once you have used left outer join, do left outer join on all the other tables. Store it as a Word file, insert all the queries after each question, save it, then send it. In a Word file, yes. हाँ, question के अंदर ही answer डाल के, Notepad is also fine. .SQL, that's also fine. We just want to see the queries. You send it in any format. It's fine with us. But this was a tough one, you know. It was a tough one to do, but if you are able to do it, you know, pat on the back. I think this week probably I'll check with them. There can't be an outer join. It has to be either left outer join or right outer join. So we are getting customer information, we are getting the order information and the product information, and this report will be very, very useful to the Flipkart manager, right? Let's just export it and let's see. Customer order, save it. Okay, so he will come to know that this person has placed these products, has ordered these products, and this was the amount that he has purchased. So this way he can find it out, who has placed what, how many. Okay, and see this customer Nisima, she has not placed an order, but still we are able to see that customer. Similarly, Ahmed has not placed an order, Hans, and these are for all the customers who have not placed an order. So what will be the benefit of getting this report? I'll probably create a campaign that whoever has not bought anything from me, I'll send them some coupon, 5% off, 10% off. Okay, so that to give them incentive to come to their site and then place an order. And also another use is, if one customer is placing a very order for a very high-end products, TV, laptop, okay, and he's our preferred customer. So what we'll do, we'll send them also some coupons that there is 5%. If you buy something more than 20,000, we will give you 10% discount. This is how we get emails, right? They are running these queries, analyzing this data, and then taking the business decision. Okay? Okay, let's take a break. We'll come back, then we'll continue with our queries. Yes? I'll 11:30, we'll zoom, come back by 11:45.
So what are the analytical functions, student? What do you mean by analytical functions, or how they operate over a data? Okay, so aggregate function we also can apply using group by, right? Right? Okay. So when we apply aggregate function on a group by, I mean after doing group by, what would be the result that we would be expecting? Let's say if we have this type of a data, let's say, okay, just a minute. Yeah, we have this type of a data. What we have is the region, okay, north, south, east, west, north, south, and then we have some region number, and then we have a cells for that particular region. Okay, let's say if I say that select average cell, okay, from this table, whatever this table name is, group by region. Okay, so what would we will be expecting there? Yeah, so what we will have is, now in this table what we have is, we have 4 region, right? So for every region, okay, whatever cells value you have, so there might be 3 cells value for one region, there might be 5 cells value for another region, there might be some 6 to 7 cells value for another region. So you can't have a common count for every region. Okay, only thing what it will do is it will see ki how many north values are there. Okay, all those values will be considered together, and on those data, okay, you will apply some or other aggregate function. So it might be sum, it might be average, right? It might be count. Okay, it might be mean, it might be max. So there are n number of aggregate functions, and you will be applying that aggregate function on that data, and what you will be getting is you will be getting a one result for one group, right? That's the main difference between Windows function and aggregate function on group by, right? So आपको क्या मिलेगा? आपको हर एक ग्रुप के लिए एक aggregate function का आंसर मिलेगा. Clear? So that's what we generally do in group by, right? Now in Windows function, obviously you again can apply aggregate function on using Windows function, but difference here is you don't get one value for one group, rather you can get n values for n rows. Okay, you can get, let's say आपके पास ये कितने हैं, insert into कितना किया हमने, almost 2 to 10, मतलब 8 records are there, right? 9 records are there. So in those 9 records, if we apply aggregate function, however, doing partition or doing order by, whatever, there are a number of ways to do it. The main thing is that don't expect one value for one group. Okay, it will be 9 values for 9 rows. Clear? Now, there is a different way in calculating those 9 values. वो कैसे calculate होता है, cumulative way से कब होंगे, cumulative way से कब नहीं होंगे, वो अलग अलग है. बट यहाँ पे क्या होता है, विंडोज फंक्शन में आप सिर्फ अप्लाई करने के टाइम पे विंडो पे अप्लाई करते हो, बट देन व्हेन यू अप्लाई इन अ विंडो यू अप्लाई इट रो वाइज, ओके, नॉट ग्रुप वाइज. क्लियर? ये दोनों का बेसिक डिफरेंस है. ठीक है. नाउ सो सबसे पहले वी नीड टू, व्हेन वी अप्लाई on any data set, when we apply Windows function on a data set, we need to first define a window. We need to first define a window over which we will be applying any Windows function or analytical function. Okay, that can be done using overclause. That can be done using overclause. So सबसे पहले आपको ये learn करना है कि overclause होता क्या है. So let's say if I write this type of a query, क्या लिखा ऊपर? Select salesman code. Salesman code is that S01, S02, S03. Region is north, south, east, west. Okay. And then sales volume. Sales volume मतलब कितना sales हुआ है. And क्या करना है आपको? आपको average करना है sales volume के ऊपर. ठीक है. We are applying aggregate function on this sales volume over. Yeah. It's not started. So you are writing that over, and at over you are not writing anything. Okay, आपने कुछ लिखा नहीं है. Okay, that means right now you are not doing any kind of a partition on your data. Okay, आपने सिर्फ over लिखा और छोड़ दिया. Can you see the syntax ऊपर? Over in bracket nothing. So generally what you need to specify here is you need to specify what kind of a partition you are making, and within that partition how ordering you want, मतलब what kind of a ordering you want. ये दो चीजें आपको बतानी पड़ती है when you apply Windows function. Okay, so remember 3 things. One is over. So over means कौन से डेटा के ऊपर आप अप्लाई कर रहे हो. Okay, so that data set. Okay, within the over you need to specify actually 3 things. Okay, but we'll not talk about third thing right now. So first you be comfortable with partition and order by, and then you will be looking at the frame part. Okay, so over in bracket we specify partition and order by, right? So partition क्या करता है, जो डेटा सेट को आपने ओवर के अंदर बताया है, okay, उसको partition करेगा. Partition by some attribute. Partition by some attribute. Okay, then उसी partition के ऊपर at a time aggregate function apply करेगा. Clear? So ये technique है. So right now we are not writing anything here. That means technically we are not doing any partition. Okay, so that particular column will be calling it as average cells from cells. Okay, सो इसका मतलब क्या हुआ, इसका मतलब ये हुआ कि आपको इस पूरे डेटा सेट के ऊपर क्या करना है, एवरेज कैलकुलेट करना है. यू आर नॉट ग्रुपिंग इट, यू आर नॉट पार्टीशनिंग इट, यू आर नॉट अरेंजिंग इट. क्लियर everyone? So whatever is your average value will be written for every row. That's the difference between your normal aggregate function using group by and this method, right? This method. So now how many average values will be getting? 9. Okay, same value obviously because सबका average same ही आएगा, but you will be getting 9 values. Clear? ये समझ में आया? Okay. Now next. Now we'll introduce partition by clause here. Okay. So partition by, now what I want to do is same query. What I am doing here, over in bracket partition by region. Clear? Over अंदर क्या लिखा मैंने, किसके ऊपर partition करना है मुझे, region के ऊपर. So now if I partition this region column, you have 4 regions, right? So all those similar regions will be considered together, will be arranged together, will be written together. Fine. So you see here, east has come together, north, south, west. So and then this will be generally arranged alphabetically. Okay, ये जो regions है ना, ये alphabetically arrange होंगे. ठीक है. Now within this region, how I want to arrange that I have not specified. Okay, right now. Okay. So next cells volume, अभी क्या करना है हमें, सेम करना है, बट अभी partition by region करने के बाद I want to perform average on cells volume, right? So average will be performed, but it will be only for one particular region. Clear? तो ये 25,000 and 34,000 का average, हाँ, will be written in front of both the records. Clear? Clear everyone? Similarly for all north region, you will be calculating average. So average of these 3 values will be written here in front of 3 rows. Okay? Fine? Yes? Okay. Next. एक मिनट, ऑर्डर बाय दिया है कि देखते हैं हम. रो नंबर है इसमें डायरेक्ट. ठीक है. Okay. Now there is one just small addition I want to tell you here. Let's say if I write like this way, okay, select salesman code, comma region, comma sales volume, comma average of sales volume, over partition by region, उसके आगे if I write order by, let's say sales volume, order by sales volume as average sales from sales, what kind of a difference you will be expecting or what kind of a different result you will be getting? Order by. हाँ, तो आपका ये जो यहाँ पे जो आपने अरेंज किया है ना, इट विल बी ऑर्डर बाय सेल्स वॉल्यूम. ओके, एक तो यहाँ पे डिफरेंस आएगा. सो स्मॉलर वैल्यू विल कम फर्स्ट, उसके बाद हायर वैल्यू विल बी देयर. जो 20,000, 50,000, 67,000 इज करेक्ट. नाउ हियर 45,000 विल बी अप, राइट, ये ऊपर आएगा. उसके बाद 50,000, उसके बाद 1 लाख एंड उसके बाद 4 लाख. ठीक है, ये ऐसा. व्हाट वुड बी द डिफरेंस इन दिस रिजल्ट? No difference or there will be any difference? So I'll not run this query, I'll directly go for this query with order by clause. Okay, okay, so this was my earlier query, simple one with partition by, right? With partition by. Now what I want to add is, I want to add order by there. Okay, so I'm writing partition by. Is there a difference? Yes. So earlier you had same value for both the rows, ना? इन दोनों का एवरेज क्या था? 29,500 ना, वो दोनों जगह पे था, दोनों रो में. अभी आपने क्या कर दिया, आपने सिर्फ यहाँ पे लिख दिया ऑर्डर बाय सेल्स वॉल्यूम. ओके, सो ऑर्डर बाय सेल्स वॉल्यूम So obviously this will get arranged, okay, and now how it is? 25,000. So when you write order by, na, it will consider a single row at a time, okay, for calculating average. Now it's not an entire partition over which you are applying aggregate. It's partition by and inside that order by. So average also should be calculated including order by clause. Okay, are you getting? So first row, when you have one partition, within that one partition you are saying order by, so first value is 25,000. So if you consider only 25,000, what's the average? 25,000. Now within that partition add one more row, so that is 34,000. What's the average of that? 29,500. Okay, so that is there for that particular partition. For a new partition again, fresh new row, so 20,000, right? So within that partition, so this is your partition, right? So within this partition, 20,000 is your first row. What's the average? 20,000. If you add one more value into it, so dono ka average, that is 35,000. Like a cumulative average. Cumulative average kaise hota hai वैसे? Then 60,000, 67,000 if you add in this partition, what's the average? 45,000. Clear? ये difference है. So you will not get same result. Right? ये समझ में आपको? So साउथ के लिए 1 लाख 4 लाख, so उन दोनों का जो भी एवरेज है. वेस्ट के लिए अगेन 45,000 फर्स्ट एंड देन 50,000, राइट? ओके, नाउ विल सी नेक्स्ट द सिंपलेस्ट एनालिटिकल फंक्शन. ओके, सबसे सिंपलेस्ट है रो नंबर. ओके, सो रो नंबर क्या करता है? रो नंबर विल जस्ट असाइन द रो नंबर टू योर नंबर ऑफ रिकॉर्ड्स. ओके, now again when you are assigning row number, you can define, you have to define over clause. If you don't write anything in that over clause, it will consider your entire data set and will assign sequential row numbers to it. Okay, अगर आपने partition by बोला तो वो क्या करेगा? Partition by partition it will assign row number. Okay, आपने order by बताया तो वो पहले arrange करेगा and then it will assign a row number. Okay, I'll execute it, then you will understand it better. Okay, okay, pay attention here. This is same salesman code, region sales volume is same. Now what I want to do is I want to assign a row number. Okay, क्या लिखा मैंने? over partition by salesman code and order by sales volume, same. Okay, as serial number. So I am assigning a serial number to each row. That's the new column name I am giving. Okay, जो भी result मुझे मिलेगा ना, जो एक नया column मुझे मिलेगा, उसको हम बोलेंगे serial number is the name of that column, right? And then average की actually जरूरत नहीं है. Look here. So what I have done is, okay, if you can interpret this result, हमने क्या बोला कि रो नंबर असाइन करना है. हमें कहाँ पे असाइन करना है? हमें असाइन करना है एक पार्टीशन के ऊपर. कौन से पार्टीशन के ऊपर? आई वांट टू पार्टीशन दिस डेटा बाय रीजन वाइज. ओके, सो इन रीजन, सॉरी सेल्समैन कोड, सॉरी नॉट रीजन, सेल्समैन कोड के ऊपर अभी हमें पार्टीशन करना है. तो same salesman code जहाँ पे होगा, that will be considered together. Okay, within this partition how I want to arrange? I want to arrange by sales volume. So sales volume will be arranged ascending order. Okay, now इसी partition में हम क्या करेंगे? हम row number assign करेंगे. So row number will be 1 and 2, right? Row number is just like a sequential number. Okay, so 1 and 2. तो ये partition खत्म हो गया. Okay, next partition के लिए फिर से row number will start from 1. Okay, it's because this partition is S2 ka partition, third is S3 ka partition, there are 3 rows, so it will go from 1 to 3 and then S4 ke liye again 1 2. Fine. So if I don't write partition number, then क्या होगा, partition by अगर हम नहीं लिखते तो क्या होगा, अगर let's say ये part निकाल दिया, so your cells volume first will be arranged in ascending order and then 1 2 3 4 in serial order, correct? So that you can expect. See here, yes, okay. Now अगर हमें ऐसा निकालना है कि you know, I want to know the second highest cells volume, third highest cells volume, कैसे निकालेंगे इसमें? Can you find out second highest cells volume here, or let's say least cells volume? Okay, so let's say अगर हमने इसे order by descending किया, what I am going to get is, हाँ, सबसे highest cells volume up, it will be on top. Second highest is your 1 lakh. I want to fetch that record. How should I get it? ऐसा क्वेरी आपको आता होगा ना, सेकंड हाईएस्ट सैलरी निकालो. हाँ, विंडोज से बताओ, रो नंबर से भी बता सकते हैं ना हम. Where serial number is equal to 2, right? क्या डेंस रैंक भी ले सकते हैं, करेक्ट. डेंस रैंक भी ले सकते हैं, रैंक भी ले सकते हो आप, नॉट एन इश्यू, बट रो नंबर विल गिव यू इन यूनिक number to each row, okay, every time. So when you write dense rank is equals to 2, कभी कभी आपको 2 rows भी आ सकते हैं, 3 rows भी आ सकते हैं ना रिटर्न में, रो नंबर में वैसा कभी नहीं आएगा. ओके, इट विल बी लाइक अ, और अगर आपके सेल्स वॉल्यूम यूनिक है, लेट्स से इफ यू हैव अ यूनिक सेल्स वॉल्यूम, देन ऑल वॉल्यूम्स विल गेट अ यूनिक नंबर ना इन रो नंबर. ओके, बताओ तो कैसे फेच करेंगे हम? वेयर शुड आई राइट दैट, वेयर सीरियल नंबर इज इक्वल टू 2, वेयर शुड आई राइट इट? ये होगा, हाँ, यू नीड टू फर्स्ट, ये जो रिजल्ट हमने जनरेट किया है ना, इसको एज अ एक डुप्लीकेट नंबर अलाइज देना पड़ेगा आपको. ओके, फ्रॉम दैट यू हैव टू फेच SR इज इक्वल टू, सॉरी, सीरियल नंबर इज इक्वल टू 2, राइट? इसको एक पूरा आप टेबल कंसिडर करोगे. ओके, कैसे लिखोगे आप बताओ? फ्रॉम सेल्स तक हम ब्रैकेट बना देते हैं, इसको बोलते हैं एज बी. वेयर बी डॉट SR नंबर, इसके आगे कुछ तो सिलेक्ट करना है ना हमें. ठीक है, that's it, it should run. Fine, ठीक है. So that's how row number will work. You understood ना, partition by क्या करेगा वहां पे, and order by क्या करेगा. If I remove order by, let's say I just include partition by, what it will do? So order by निकाल दिया, सिर्फ partition by रखा, तो how it will arrange? As they are faced. तो as per your database. Okay, database में जैसे होंगे ना वैसे ही वो fetch होंगे. So you are just operating on partition, not with specific order. Okay, तो जो ऑर्डर से वो डेटाबेस में है उसी ऑर्डर से वो रो नंबर असाइन करेगा. क्लियर? Lag and lead. Okay. Do you know what is lag value and lead value in Windows function? Okay. Lagging का in general meaning क्या है? Lagging and leading. Lagging means behind, right? Generally lagging means behind, and leading means after, right? मतलब आगे है. Okay, so lag Windows function will return a value for row before current row. So right now, let's say if you are working in one partition, within that one partition, let's say if you are working in a second row, okay, तो lag क्या करेगा? उसके पहले वाले रो का वैल्यू असाइन करेगा सेकेंड रो को. ठीक है. For first row, it will be null. For first row, it will be null. Are you getting? Let's say if you have a partition, within that partition you have a 3 values, right? 1, 2, 3 or 3 rows. 1, 2, 3. Now, lagging row for first row will be nothing, right? You don't have a lagging row for first row. तो उसका जो value होगा, it will be null. For second row, it will be first row. For third row, it will be second row. Clear? Again, lag कितना लेना है वो आप specify कर सकते हो. मतलब immediate last row को लेना है, और you want to have a 2-3 frames at a time considered as a lagging frames or lagging rows. Okay, that you can specify कि कितने row को at a time consider करना है lagging rows को. So previous 1 row consider करना है, previous 2 rows consider करना है, previous 3 rows consider करना है, like that. Understood? That frame you can define. So let's say this simplest of example. हमें क्या करना है? Select salesman code. अभी हमने lag किसके ऊपर लगा दिया है? Lag हमने sales volume के ऊपर लगा दिया. तो sales volume column में previous sales volume for this particular row will be written here. Okay. So now what you are doing is order by region. That doesn't matter actually. Now हम क्या कर रहे हैं? यही सेल्समैन कोड के लिए, so S03 के लिए what we are doing, we want lag of sales volume. So first row के लिए it will be nothing, ना? First row के लिए कुछ नहीं है क्योंकि इसके पीछे you don't have any specific value. Okay. Now for second row it is the first row. So इसका जो भी sales volume होगा that will be written here. फिर third row के लिए second row का जो sales volume है वो यहाँ पे आएगा. ठीक है. डेटाबेस से आपको अच्छे से पता चलेगा. We'll copy paste this. Okay. Okay, what was your database? Database is here. Okay. So what is our condition? Our condition is salesman code is S03, right? So for all S03 salesman, कौन से है देखो, ये है row, this is your one row S03 having 25,000 cells. Okay. फिर 1 lakh and then S03 67,000. Now in these 3 rows, am I specifying any order? Yes, I am specifying an order, right? Order by region, correct? अब मुझे बताओ what will be the, let me print region also here. Okay, so region we are ordering, right, alphabetically. So east value will be first, then north and then south, right? If you look at alphabetically. Now east का सेल्स वॉल्यूम भी प्रिंट करके देखते हैं हम यहाँ पे. ओके, लुक हियर एवरीवन, नाउ यू विल अंडरस्टैंड प्रॉपर्ली. ये हमारा ओरिजिनल सेल्स वॉल्यूम कॉलम है. हाँ, ये हमारा ओरिजिनल सेल्स वॉल्यूम कॉलम है. अभी हमने लैग के लिए क्या बताया? लैग ऑन विच कॉलम? लैग ऑन सेल्स कॉलम, राइट? सेल्स वॉल्यूम कॉलम. ओके, so order by, ठीक है. Now when you lag, that means this is your previous volume. So हम सिर्फ इसको नाम दे रहे हैं lag column को previous cells. ओके तो हम ये बता रहे हैं कि इस सेल्समैन का प्रीवियस जो सेल्स था वो 25,000 था, ऐसे वो कहां से ले रहा है, प्रीवियस रो से. ओके नाउ फॉर दिस रो व्हाट इज योर लैगिंग रो, प्रीवियस रो ना, उसका जो सेल्स वॉल्यूम है वो यहां पे आएगा. समझ में आया, दिस लैग. व्हाट विल बी लीड, अगर लैग को चेंज करके हम लीड लिखेंगे तो नेक्स्ट रो, राइट. ठीक है, फाइन. समझ में हाउ लैग एंड लीड वर्क्स हियर. कैन वी डू पार्टीशन बाय, लेट्स से अगर हमने ये निकाल दिया, सेल्समैन कोड नहीं रखना है हमें स्पेसिफिक कुछ. ओके व्हाट आई वांट टू डू इज I want to partition by region, order by sales volume. Okay, partition by region, order by sales volume, and within that partition, I want to apply lag. Can you do that? Just can you suggest me the query for your partition by region? So, ठीक है, एंड लैगिंग ना, लैगिंग. फाइन, यही एक्सपेक्टेड है हमें, है कि नहीं. सो within this partition I want to arrange how I want to arrange by sales volume. Okay, and then lag. So previous sales will be lagged by one row ना, this will be lagged by one row, मतलब इसका वैल्यू नल आएगा and इसका वैल्यू 25,000 आएगा, इसका नल आएगा, इसका 20,000 आएगा, इसका 50,000 आएगा, because in this partition I am doing lagging, within the partition I am doing lagging, right everyone. See, ये याद रखना हमेशा, विंडोज में एवरीथिंग हैपेंस ओवर अ पार्टीशन. ओके, within that partition you will be applying row wise any function. Okay, partition खत्म हो गया, उसके बाद रीस्टार्ट करना है आपको, you need to restart for next partition. Clear? Okay, this is league. क्या लैगी है, ठीक है, वही है जो हमने किया है, लीड, राइट. लीड हमने देखा ना अभी जस्ट. ओके, कैन यू टेल मी व्हाट इज फर्स्ट वैल्यू. फर्स्ट वैल्यू पता है आपको, फर्स्ट वैल्यू का मतलब लिटरल मीनिंग क्या है फर्स्ट वैल्यू का, फर्स्ट वैल्यू, राइट. सो फर्स्ट वैल्यू इन दैट पार्टीशन विल बी रिटन अक्रॉस ऑल द रोज ऑफ पार्टीशन, राइट. लेट्स से अगर मैंने ऐसे लिखा, so lag की जगह पे if I write as let's say previous cells की जगह पे हम बोलते हैं initial cells, है कि नहीं, first value. So it will be, look here, initial cells, मतलब within this partition was the first value, if you apply order by, was the first value 25,000, that is your initial cell. That initial cell will be written everywhere. Okay, okay, fine. There is something called the nth value. What will be the nth value then? So you here can specify nth number, कौन सा वैल्यू आपको चाहिए, फर्स्ट चाहिए, सेकंड चाहिए, थर्ड चाहिए, फोर्थ चाहिए, फिफ्थ चाहिए, एन वैल्यू यू कैन स्पेसिफाई हियर, राइट. रुको एक मिनट, उसका स्पेसिफिक एक एग्जांपल है मेरे पास. So let's say now I'll not do partition by. Okay, partition by से क्या होता है ना, within that partition nth value मिलना थोड़ा मुश्किल है हर बार, क्योंकि आपके पार्टीशन छोटे भी हो सकते हैं. आपने बोला fourth value in that partition, and if you just have a partition on 2 rows, you can't get fourth value in that partition, right? So I'm just removing partition by clause there. Okay, so I'm just writing nth value here. Okay, nth value on this cell's volume. I need to specify now number. nth value में मुझे number specify करना पड़ेगा ना, क्योंकि nth का value क्या है यहाँ पे. Okay, let's see if I say 3. Okay, so what you will be getting is, हमने partition by हटा दिया है, ठीक है, partition by हटा दिया. Now your cell's volume is arranged by arranged in ascending order. Now in this order, what's your nth value? Third value is 34,000. So यहाँ से वो copy paste होगा. So from here 34,000 everywhere will be copy pasted. For first 2 rows it will not be anything. It will be null. Okay, so n minus 1 rows के लिए it will be null. Nth rows से, okay, that value will be copy pasted. Clear? Or just same for all the rows. Clear? Okay, can you apply partition by here? कर सकते, not an issue. कर सकते हैं. Let's say अगर हमने partition by, let's say हमने लिखा है region करते, region order by cells volume, ठीक है. ओके, थोड़ा हम nth वैल्यू थोड़ा कम कर देते हैं, क्योंकि अदरवाइज सब जगह पे नल आएगा. देखो, now within that partition, within that partition second value, so 25,000 के आगे कुछ नहीं आएगा, it will be null. Okay, what is your second value? Second row 34,000. So actually nth value मतलब basically वो nth row से ही चालू करता है calculation. It's not only nth value, it takes मतलब first n minus rows को it will not do anything. Nth row से ही it will I mean frame will start from nth row itself. Okay, the frame will start from nth row. Nth row पे what's the value that will be taken. Clear? जो भी cells volume है आपका वो लिया जाएगा as a nth value. Clear? As a nth value. Understood? Okay, it will start operating from nth row itself. Clear? ये समझ में आया? ठीक है, तो ये ठीक है. Okay, then there is something. There is one important function, entile. Entile. Have you heard about it? Entile. Okay. Entile क्या करेगा? देखो, मैं लिख के बताती हूँ तो आपको शायद समझेगा. And ये बहुत famous question है. What's the difference between entile and nth value? Because students generally get, दोनों का relation नहीं है वैसे तो, but students get confused because of similar name. Okay, pay attention everyone. Pay attention. जैसे अभी 1-2 ही बाकी है, फिर सब खत्म हो जाएगा. अब मैंने partition by हटा दिया है. Okay, I'm not looking at the data by doing partition. Just मैंने order by रखा है. तो your cells volume will be arranged in ascending order. In that data set, what I want to do is, in that particular table, what I want to do is, I want to form a n tiles. N tiles मतलब n groups. Okay, और n groups के n का वैल्यू है 3. मतलब मुझे क्या करना है, मुझे 3 ग्रुप बनाने हैं. इन शॉर्ट मुझे क्या करना है, 3 ग्रुप बनाने हैं. अब अगर हमें 3 ग्रुप बनाने हैं, हमारे पास कितने रोज हैं? 9 रोज है. कैन वी डू इट इक्वली? इक्वली कर सकते हैं ना. तो क्या होगा, फर्स्ट 3 रोज को ग्रुप नंबर 1 बोला जाएगा, सेकेंड ग्रुप को आपका ग्रुप नंबर 2 हो जाएगा, और थर्ड ग्रुप आपका ग्रुप नंबर 3 हो जाएगा. ये समझ में है? 1 1 1 2 2 2 3 3 3. Clear? Entile मतलब it just makes a 3 group or n groups in your table. ओके जैसे आपने बोला है वैसे, आपने बोला ऑर्डर बाय तो ऑर्डर बाय से करेगा, डिसेंडिंग ऑर्डर बोला तो डिसेंडिंग ऑर्डर में करेगा, ठीक है। पार्टीशन बाय बोला तो पार्टीशन करके ग्रुप करेगा, ओके। सो पार्टीशन बाय किया तो विद इन द पार्टीशन 3 ग्रुप्स, ओके। आपको समझ में आ रहा है मैं क्या बोल रही हूं? okay. मैंने यहाँ पे पार्टीशन नहीं बोला है, पार्टीशन नहीं बोला है, इसका डायरेक्ट मीनिंग ये हो जाता है कि आपका पूरा टेबल इज 1 पार्टीशन, ठीक है। पूरा टेबल एक पार्टीशन है। उस पूरे टेबल में मुझे कितने ग्रुप बनाने हैं? मुझे 3 ग्रुप बनाने हैं। 9 रोज आर देयर, 9 रोज आर देयर, इक्वली कर सकते हैं, तो वो क्या करेगा 3-3 रोज को एक एक ग्रुप बनाएगा, ओके। अगर मैंने यहाँ पे 4 बोला, इफ आई से 4, ऑब्वियसली 1 हैज टू बी ऑड ग्रुप, है कि नहीं? एक में कितना जाएगा? सो इफ आई वांट टू मेक 4 ग्रुप इट विल बी 3, then 2 2 2, right? And always first will be having more number of rows than second, ये याद रखना हमेशा। फर्स्ट ग्रुप जो रहेगा उसमें ज्यादा रोज रहेंगे, सेकंड में कम रहेंगे, okay? So I'll just execute this, then you'll understand. See, first group 3 rows, 1 1 1, later on 2 rows each, later on 2 rows each. So can I make 5 groups? Yes, 5 भी बना सकते हैं, 6 भी बना सकते हो, ठीक है। सो जितना मैक्सिमम इक्वली होता है उतना इक्वली करता है। अगर इक्वली नहीं हो पा रहा है तो इट विल ऐड 1 रो इन जो पहले वाले ग्रुप्स है ना उसमें एक एक रो ऐड करेगा वो, क्लियर? ओके, सो एंटाइल हम 3 करते हैं। अब पार्टीशन बाय लगा के देखते हैं। Okay, student, please. Can you interpret this result? Entile का result can you interpret? मैंने बोला entile 3, but I am specifying now partition, right? So that means within the partition I want to make 3 groups. Okay, I want to make 3 groups, but then there are only 2 values ना here. So 3 groups. अगर आपके पास उतने रोज ही नहीं है, बेसिकली आपके पास उतने रोज नहीं है तो वो नहीं बना पाएगा ना, इट विल बी जस्ट 1 रो 1 ग्रुप, है कि नहीं? दैट्स व्हाट हैज हैपेंड फॉर ईस्ट एंड साउथ एंड वेस्ट। ईस्ट रीजन के लिए आपके पास 2 ही रो है, आप बोल रहे 3 ग्रुप बनाओ, नहीं है पॉसिबल। सो ग्रुप नंबर 1 is 1 row, group number 2 is 2nd row, that's it. Okay, now for north region you have 3 rows, 3 groups, so 1 2 3, clear? Clear everyone? समझ में आया? And then you have last 2, dense rank and rank. Dense rank and rank. So what is dense rank? ये आपने बहुत बार किया होगा ना, dense rank and rank तो बहुत बार किया होगा। क्या होता है dense rank? So let's see if I write यहाँ पे, if I write like this, rank, let's say rank number. So I'm arranging it in descending order. So highest will get first rank, okay, 4 lakh. उसके बाद second highest, second rank. Now wherever you have a common value, you will get a same rank, okay, 4 and 4. But then 5 will be skipped in that case because I am writing rank. Okay, 5 will be skipped. Next rank will be 6, 7, 8, 9. Okay, and if you apply dense rank, that 5 will not be skipped. So next rank will be 5. Okay, so that's the only difference. और ये सबसे simple है, कि नहीं? 1 2 3. Now 4 and 4. Okay, 5 50,000 is 4 and 4. 5 will not be skipped. So 5 will be the next rank for 45,000. Okay, कोई भी नंबर स्किप नहीं होगा इसमें, ठीक है? So I'll give you some questions. Can you practice on these analytical functions? Yeah, I'll just upload it on Olympus. समझ में आया सबको? आप क्वेश्चन सॉल्व करोगे? हाँ, ब्रेक, हाँ आप जाके ब्रेक, take a break for 10 minutes. I'll just upload all those documents.
This brings us to the end of this SQL tutorial. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So thank you very much for attending the session. Have a great learning ahead.